We're in.
Shall we play a game?
How about global thermonuclear war?
Hey there, HackerFrogs. It's me, the Shy Hat. All right, everybody, we're going to be doing HackerFrogs after school today, and we've got a few different topics that we're going to be going over in today's live stream, as per usual. So, the first thing we're going to be doing is we're going to be doing HackerFrogs After School Binary Hacking Basics Part 1. So this is a course in development over here at HackerFrogs, and we're trying to learn about how to do binary hacking, that is, hacking programs, and that's going to involve understanding how program flow execution works, and that's going to be in the first part of today's stream, which is Part 1. Anyways, let's move on to talking about what we're going to be doing next, which is going to be Overthewire Natas. And Overthewire Natas is a web app security lab where we get to take a look at how server-side web security can be done. So we've been doing quite a number of these demonstrations for these web app hacking CTF exercises, and we're going to be continuing on with that. And we're going to be doing a demo for level 14 and level 15. So please look forward to that in the second hour of today's stream. And in the third hour of today's stream, we're going to be continuing on with more Natas CTF challenges. We're currently trying to work through all of the challenges over at the Natas CTF game. There's a total of 34 levels, and we're currently on level number 19. So we're going to see if we can finish at least one level today, maybe two if we're lucky, and that's going to be in the third and fourth hours of today's stream. All right, everybody, let's go ahead and get started with HackerFrogs After School Binary Hacking Basics, Part 1. Okay, so in order to do these exercises, you're going to have an account over at PicoCTF. If you don't already have an account over at PicoCTF.org, then you can go ahead and make one over at this link that I'm providing in the chat right now. Just a second. So the account over there is going to be free. You don't have to pay for it. So anybody can go ahead and sign up for that account and then participate with us when we come to the interactive exercises. So all right, let's get into this. So welcome to HackerFrogs After School. HackerFrogs After School is a cybersecurity program for learning beginner cybersecurity skills across a wide variety of subjects. This workshop is the Intro to Binary Hacking. So what is binary hacking? So binary hacking is interacting with a compiled computer program. These are called binary executables, which results in an unexpected response that is beneficial to the user interacting with the program. So it's basically getting the program to do something that it's not supposed to do in order to get some sort of benefit for the person who is doing the hacking, or that would be the hacker. So in this introductory workshop, we'll be taking a look at a couple of examples of compiled programs that have been coded in such a way that they can be hacked by anybody who can identify the vulnerability. So we like to incorporate CTF exercises into our classes for a more interactive experience. But what are CTFs? So this is a very common question for people trying to get into cybersecurity. They hear about these CTFs, they hear CTF, 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 but what are these things? So cybersecurity Capture the Flag, that is CTF games, are training exercises where the goal of the exercise is to capture the flag through use of cybersecurity skills. In this context, capture means to gain access to a file or other resource, and flag refers to a secret phrase or password. The CTF game we will be playing to learn basic binary hacking is called PicoCTF, which is one of the most well-known and well-respected CTF games, and is affiliated with Carnegie Mellon University. The PicoCTF game is made up of many challenges across different categories and difficulty levels. For this lesson, we'll be looking at a couple of PicoCTF challenges in the binary hacking category. So, when we talk about binary hacking, we're mostly going to be talking about memory hacks. So a well-known type of binary hack involves memory vulnerabilities, which occur when a program is written in an insecure way. So this is a demonstration of 8-bit bandits, 8-bit bandit. 8-bit bandit just subscribed with Twitch Prime. Thank you very much for the subscription on Twitch, 8-bit bandit. And why don't I give you a fun little video redeem? How about this one that is from South Park?
Mr. Hat, may I please be excused from class?
Well, Kyle.
Yes.
You hear me? You go to
Hack.
You go to
Hack.
You
Have a great day.
Thank you very much, 8-bit bandit, for the subscription with Prime on Twitch. I hope you can have a great day and go to hack. All right, so let's continue on. Okay, so this is a little visual representation of the memory space inside of programs. So we've got what is called the stack, the heap, static data, literals, and instructions. So we'll talk a little bit more about what exactly this memory space contains in just a little bit. So memory vulnerabilities occur when a program is written in an insecure way, and this allows users to inject arbitrary data into a program's memory space, which can result in any or all of the following things. So it could crash the program, it could allow access to other functions in the program, or it could allow arbitrary command execution on the program's host system. So these are all really bad things, and they could all be achieved through this through hacking the program memory. Another thing that we're going to be talking about quite often in today's workshop is memory buffers. So in order to understand memory hacks, we must first understand the concept of memory buffers. So in programming, memory buffers are sections of a program's memory space that are set aside to hold data, for example, user input. So there's this little space inside the program's memory where you can put all of these variables or user input. For example, we could put this word, password, inside of a memory buffer over here, and each letter in the password is going to take up one of these bits in the buffer. So in C programming, the amount of space allocated to each memory buffer must be specified. So when you're writing C programs, you have to specify how much space each one of these variables is going to take up, because if you don't, then there's going to be trouble. So for example, a buffer meant to store a user's password may be set to 8 bytes. So each character in a password requires 1 byte. So the maximum length of that password should be 8 characters. But what happens if the program receives input for that password which exceeds 8 characters? So data in excess of 8 bytes will overflow out of the specified memory buffer into the neighboring memory space, overwriting the data that was there previously. So let's just say that you assign a can of water, and so for all the data, and if somebody puts more than the can's worth of data of water into, well, this is a really weird metaphor, but anyways, it's gonna the excess water is gonna spill out into other areas. So basically, the spaces are only allowed to hold a certain amount of data, and if you put more than that amount of data, then it's going to overflow into other parts of the program. So in programming, the act of data escaping the memory buffer allocated to it is known as buffer overflow. So you're going to hear a lot about this kind of stuff when you're talking about binary hacks, memory buffers, buffer overflow, and the like. So we're going to be talking about some different aspects of memory hacking by working through an exercise over at PicoCTF. So to learn more about buffer overflows, let's take a look at a challenge in PicoCTF. So what you want to do is you want to log into PicoCTF, and after you've done so, you want to navigate to this page over here, and I'll just provide the link to everybody in chat, and we'll also go to the link ourselves. So make sure that you're logged into PicoCTF. and then paste in the link for the challenge. And we're going to see that this is the buffer overflow 0 challenge over here. So actually, we're getting a little bit ahead of ourselves. What we want to do first is we want to set up an environment where we can solve this challenge. And in order to do so, we can use the PicoCTF web shell. So make sure to log into PicoCTF, and then after you've logged into PicoCTF, you want to click on the practice section over here. So along the top, there's this practice section. Go ahead and click on that. And then afterwards, you can scroll down a little bit in the web page. And after you scroll down a little bit, you're going to see this button over here on the right-hand side of the screen. The button is labeled Web Shell, and that's going to give you access to the Linux virtual machine that you're going to be using to solve the challenge. So go ahead and click on that Web Shell button, and then you're going to see the Web Shell pop out here. And it's going to be, this is a little Linux virtual machine. So the problem is that we want the virtual machine, we want the web shell to be big, because this is a little bit cramped, and we really want it to be in full screen. So we can actually make it full screen by going up to the top of the web shell and then moving over to the buttons over here. So beside the help button to the right is this button labeled Pop Out Web Shell Terminal. So you can go ahead and click on that button, and that's going to start up the web shell terminal in its own browser tab. This is what we want, because we want everything to be nice and big so that we don't have to strain our eyes looking at this stuff. So if for some reason you click on the button and it doesn't give you this response over here with the web shell, then what you want to do is you want to try again, because the servers over at PicoCTF are pretty heavily used, and sometimes they're not very responsive. If for some reason you're not able to load it up the first time, I want you to try a few different times, and eventually you're going to get access to the web shell here. After you've done that, you can clear the screen by typing in clear and then hitting enter. And you'll know you're logged into the web shell because you're going to see your username and then dash and then PicoCTF at web shell. This is going to be the terminal prompt. So from here, you can use the ls command to see what's in your directory. You can get rid of whatever's there. What we're going to do is we're going to download the challenge file to actually there are two challenge files, and we're going to download them to this web shell over here. If you're having trouble opening up the web shell, please let us know in the chat, and we'll try to help you out. Remember, you have to be logged in order to access the web shell. Okay, so after you've accessed the web shell, we're going to go over to the challenge link, and the challenge link is in the chat. Paste that into your web browser, and you're going to see this challenge over here. So let's go ahead and read the description here. This is a buffer overflow 0. It is a medium level challenge in the binary hacking category from the PicoCTF 2022 event. The description of the challenge says, let's start off simple. Can you overflow the correct buffer? The program is available here, and here is a link. You can also view the source here, and here is also a link. So there's two links that we need to download to our web shell in order to do the challenge. So I want you to go to the first link, and then I want you to right click on it and then select copy link. After you've done that, I want you to go back to your web shell, and it looks like our web shell was disconnected. If you do not send a command to the web shell after a certain amount of time, it's going to disconnect you, but that's fine. To reconnect, all you need to do is click into the terminal and hit the enter button. Okay, so what we're going to do is we're going to download the two files required for the challenge by using the wget command. So go ahead and type wget and then space, and then you can right click and then paste in the file address over here for the vulnerable program for the challenge. Go ahead and hit enter after that, and then you're going to see that the vulnerable program is now in your directory now. Okay, so we need to do this one more time because there's one more file we need to download. So we're going to go back to the challenge, and we're going to go to the second link. And for the second link, we're also going to right-click and select Copy Link. Then we're going to go back to the web shell, and we're going to use wget one more time and paste in the address, and then download the other file. So we got 2 files in here. So one of these files, the vuln file, this is the actual vulnerable binary that we're going to take a look at. And the other file, vuln.c, this is the source code that was used to create this this program file over here, vuln. So what we're going to do first is we're going to try to understand what exactly the program is doing before we start before we start hacking against it. So what we can do is we can use the nano text editor to take a look at the code inside the vuln.c file over here. So nano space vuln.c and then hit enter. So let's make this a little bit smaller. Okay. All right, so we've got, this is C code over here, written in the C language. And I want you to understand what is going on in this code before we start running it, okay? So what's going on? I'll try to explain what's going on to the best of my ability. I'm not super good at coding in C, but I'll try to explain what's going on inside the code. So first of all, we're going to include a bunch of C libraries. That's going to let us use the rest of our code. And then we're going to define the size of a flag. So remember that we said that in C, we have to define the size of our variables. So in this case, there's a variable called flag size max, which is set to 64 bytes. And then we define a string, which is called flag, and that's set to a number of bytes equal to flag size max. Thank you very much for following on Twitch. PicoCTF88, thank you very much. And why don't you have Hack the Planet on me? There you go.
Hack the planet! Hack the planet! Shut up and get it!
Thank you very much for following PicsYD. PicsYD, you are now a HackerFrog. Okay, so next thing we have is we got a little function, a little programming function over here, and this is called the sigsegv handler. And sigsegv, this is something called a segmentation fault inside of Linux, and it means that the program crashed because it tried to access a bad memory address. So this takes in the argument sig, and it's going to print out something, and then it's going to print out the flag. So what it's going to do is it's going to print out the flag, and then it's going to exit the program. So this is actually what we want to do, because the goal of all of these CTF exercises is to read the flag file. If we manage to get this function to run, then we win the challenge. Senor Goomba says hello, says what's up? Hello, Senor Goomba, nice to see you here. Why don't you have a Nyan Cat? And welcome to the stream. Okay, so we're just investigating this this vulnerable code over here. If you want to join in yourself, you can have one of the. You can go ahead and go to this link inside of PicoCTF, and you can join in with the challenge over there. Okay, so we're just taking a look at this this code. So what we want to do is we want to execute this. We want to execute this this function over here, because this function is going to print out the flag for us. So what we need to do first is we need to make sure that there is a flag.txt file in here, because if there's no flag.txt file, it's going to print out this program over here and then exit. Please create flag.txt in this directory with your own debugging flag. Okay. Let's exit out of here real quick, and then let's create that file. Kitten Barf on YouTube says, a bunch of emotes. Thank you. Thank you very much, Kitten Barf. Okay. Let's go ahead and create that flag. So we're just going to create the flag. We're going to echo out. Let's echo out, we got the flag, smiley face. And let's output that to flag.txt. Bipolar says Frog King on top. I'm the Hat King, but the Frog is my partner. Anyways, thank you very much for coming by, Bipolar. Nice to see you on YouTube as well. And why don't we give you a desert frog? This is the cutest frog in the world. Okay, so, that is pretty cute. Okay, we're going to talk about what function in the program is actually going to give us our buffer overflow. And let's go over here to this part of the program. So in this part of the program, it's going to print input something, and then it's going to define buffer1 as 100 characters. And then it's going to use this function right here, gets, to get our user input. And it's going to save it to the variable buff1. The next thing it's going to do is it's going to pass the buff1 variable into the vuln function. So the first thing that we need to investigate is this gets function. So the gets function is actually a vulnerable function. And let's talk about why it's vulnerable. So let's talk about segmentation violations. So the goal of the exercise is to cause a segmentation violation, because if you do so, it's going to print out the flag. OG says, do you remember me? Can you refresh my memory? If you refresh my memory, I might remember. Thank you. Okay, so segmentation violations are also known as segmentation faults. These are a condition that cause programs to crash. They occur when a program attempts to read or write to an illegal memory space. So Senior Goomba asks, are those write-ups for PicoCTF? Are these write-ups for PicoCTF? No, these aren't well, we're solving the challenges right now. I don't have write-ups available for these challenges. OG says, I'm the guy that used to tell you to do delete code or do leet code. Do leet code or do leet code. That's a great, what is it? What is it called? Oh gosh, what is it? An ultimatum, right? It's either do leet code or do leet code. Unfortunately, we're not doing leet code today because we're doing binary hacking today. But if you want to learn some binary hacking, please feel free to stick around. Okay, so segmentation violations. So it's basically causing the program to crash because it encountered an illegal memory space. So in this context, an illegal memory space is a memory location that doesn't exist. In the context of buffer overflow hacks, they often cause segmentation violations, which lead to program crashes. So the way we're going to be overflowing the buffer in this case is the gets function. But what is the gets function? So OG said, no, you said to refresh my memory back then I used to tell you or comment do leet code. Do leet code. Do you remember me? I remember there was one viewer who asked me to do leet code, and they said that that what I was doing at the time wasn't very interesting. Anyways, Senior Goomba says, I have to get back to HTB. I use 5-minute breaks when I finish a part of a table of contents, so I'll be back when I'm done with one. Awesome, Senior Goomba. Yeah. So come back when you have some time, and I appreciate you coming by to chat. And OG says, that was me. Yeah, I don't, I mean, we're not going to be doing leet code, but I don't blame you for saying that you wanted to see me doing something else. Okay, so the gets function, this is the function that is going to be used to get our buffer overflow. And what the gets function does is it's used to save user input to a variable in C programming. So basically, we're using the gets function to get our user input. However, the gets function doesn't check the size of the user input, which means it can be used for buffer overflow attacks. So it says here that the buff1 variable is set to 100 bytes, but the gets function doesn't check to see if the user input is less than 100 bytes. So that's why it's vulnerable to buffer overflow. OG says, I mean, you finally start doing coding back, then you used to do some Linux terminal down the flag. Linux terminal down the flag. Yeah, we did teach a course on Python programming, and that was to help people get into cybersecurity, because people who do cybersecurity have to interact with all sorts of Python scripts and stuff. But I'm not really a programming or coding streamer. That's not my main content. I hope you understand. Okay. So if a user inputs a string that is longer than 100 characters, a buffer overflow will occur. So we've got room for 100 characters in this buff1 variable. But if we send more than 100 characters, that's going to cause a buffer overflow. So what is the string copy function? So string copy, this is another function that's used in this program. The program also makes use of the string copy function, which copies the value of one variable to another. So inside the vuln function over here, it uses the string copy function to copy the value of input into the buff2 variable. But the buff2 variable is set to 16 characters allotted to it for memory space. So if the input is more than 16 characters, then there's going to be a buffer overflow that happens there. So here it copies the value of the input variable to the buff2 variable. String copy is another insecure function because it does not check the size of the data that is being moved. Okay, we've got ads on Twitch. So when ads happen on Twitch, we need to do ads on YouTube, and we're going to watch some bird videos. So I've got a couple of new bird videos that we can watch while we have a little water break. So I'm just going to take a little bit of water, and I'll be back in just a few moments. Okay, so yeah, so this is these are my favorite birds. They're these little stellar jays. We're just doing a little break because I don't want anybody to miss any of the lesson because they're watching ads on Twitch. So we're just doing this little break while the ads run out over on Twitch and YouTube. But 8-Bit Bandit, I do see your message, and I will address your comment after the break is over. So that's going to be in about 20 seconds or so. So I like, I really like looking back at the bird feeder footage over here because it reminds me of a better time. This footage was taken in summer when it was a lot nicer out. I wish it could be summer now. Anyways, let's go ahead and take the birds away, and then let's address 8-Bit Bandit. 8-Bit Bandit asks a question. Just curious if there are any real-world applications today that still use or are vulnerable to buffer overflows. I've heard a lot about them being a big deal back in the 90s, but do they still show up in modern systems? So I would say that that buffer overflows are much less common now than they used to be. But you will still see buffer overflows happening at high levels in modern software, but it is relatively rare. The reason why we will be solving some very easy binary hacking challenges over here, but that is to say, there are applications for more advanced binary hacking techniques, and some of them are buffer overflows. They're usually not stack buffer overflows, but they're heap buffer overflows. And I'll explain what that means in just a little bit. Okay, so anyways, let's talk about the string copy function. So string copy is another insecure function because it does not check the size of the data that is being moved. So input could be bigger than buff, and if that's the case, there's a buffer overflow. So since the size of the memory buffer for the buff2 variable is 16 bytes, if the size of the data in the input variable is larger than 16 bytes, buffer overflow will occur. So let's learn a little bit more about buffer overflow. Oh man, okay. So let's go ahead and solve the, this is where we solve the challenge. So back at the web shell, we're going to be taking a look at how we can use the gets function to overflow the buffer, because the gets function is being passed. Well, the information from the gets buffer is passed to buff1, and buff1 is being passed to buff1. So buff1 is being passed to the vuln function, and the vuln function is going to set the input as buff2, and then buff2 is going to be copied. And because the input is probably going, well, we're going to make sure that the output is bigger than 16 characters. So this is going to trigger the buffer overflow. So let's go ahead and do that. So let's go ahead and exit out of Nano, and we're going to see that we can't execute the vuln program here because it's not executable. So we're going to need to use the chmod +x command to make the executable. So let's go ahead and do that. Senior Goomba, that was very quick. You are now back. Awesome. So now that the vuln file is executable, thank you very much for following Sumari ID. Is that how you pronounce your name? Thank you everyone for following on Twitch. Yeah, Twitch. Have a hack the planet. There you go.
Hack the planet! Hack the planet! Shut up and get in.
So we're going to run the vuln program over here, and since we've been taking a look at the source code that was used to create the program, we should be able to overflow the buffer and then get the value of the flag. So it says here, it's asking for some input. And remember that the input buffer, well, actually we're not overflowing the input buffer, but we are overflowing the character 2 buffer, or no, the buff2 buffer, which is 16 characters long. So if we send 16 characters, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, that's 10, and then 1, 2, 3, 4, 5, 6, this is going to fill up the buffer. What we need to do is we need to exceed the number of characters in the buffer, and typically we need to exceed the number of characters in the buffer by either 4 or 8 characters, or 4 or 8 bytes, because that's the size of the of each memory chunk inside of these programs. So if we send an extra 4 characters on top of the 16, actually no, first of all, let's just see what it looks like when the program exits normally. So this is 16 characters. We send this, and it says the program will exit now. That's fine, because we didn't overflow the buffer. So we're going to do this again, and we're going to send our 16 bytes, but we're going to add another 4 to overflow the buffer. So 1, 2, 3, 4, and then we're going to send it. So we get the message here, we got the flag, and that's because we triggered the zigzag event function, which printed out the flag. So let's go ahead and do this on the actual application, and then we can get the flag for the actual challenge. Senior Gumbo says, I'm doing the introduction to web application for a bug bounty course, and I'm on, injection. That sounds like a lot of fun. We're going to be doing some web app hacking stuff ourselves a little bit later today. So let's go ahead and go back to the PicoCTF challenge. So it says additional details will be available after launching your challenge instance. And there's a little launch instance button over here. We just need to click on that. And then it's going to give us a command we can use to access this program that we've been taking a look at on a remote server. So this is the command over here. We're using netcat to connect to the server, which is running the program we're looking at. So we can copy this command over here. Then we can go back to the web shell. And then inside the web shell, we're going to paste in the command. and we're going to give the command. So it's going to ask for input, just like in the program that we downloaded. So we're going to send 20 characters in order to overfill the buffer and cause a crash. So we're going to send 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 20, and this should be enough to get our flag. Send this, and we get the flag. So PicoCTF, overflows aren't that bad. Okay, so let's go ahead and copy this, then go back to the challenge, and in the flag submission field, we're going to paste in our flag and click on Submit Flag. Okay, it says, hooray, we've solved the challenge. Awesome. All right, so we're going to be moving on to our next challenge now. And then after we go to the next challenge, we're going to be talking about a few more binary hacking concepts. So over here. So to learn more about buffer overflows, let's look at another challenge in PicoCTF. So this is the link. I'll copy it to the chat. There you go. And let's go ahead and access the challenge in PicoCTF. Okay, so let's take a look at this challenge. MD Shamur Rahman Safat says, I have a problem. If you tell us about your problem, we might be able to help you out with that. But welcome to the stream. So this is the Format 0 challenge. And this is another one of these binary hacking challenges. The description says, can you use your knowledge of format strings to make your customers happy? Download the binary here, download the source here. So we've got another pair of files that we need to download. So we're going to do that, but first of all, we need to go back to our web shell. So let's see. MD Shamir Rahman Safat says, in Cyber Talents, there's an OSINT problem named Lake. Can you solve that? I can't solve your CTF challenges right now because I'm teaching a class. So I'm teaching about binary hacking. But yeah, maybe later, but definitely not now. Okay, so first of all, let's get rid of these two files that are in here first. We want to keep a nice and clean file format. Okay, so we're just left with the flag.txt file in here. Okay, so let's go ahead and download the files for the next challenge. So we've got two links, so we're just going to copy the links and we're going to download these two files. So wget, right click, paste, and okay, I didn't want to click on that. Okay. And for everybody's reference, after you've downloaded whatever file name after that, you can actually go back to your history, and then you can put the .c onto the end of the file, and that's going to download the source code for the file as well. So the first file was format string 0, and the later file was format string 0.c. So you can also do this manually by clicking on this link over here, the second link. And let's go ahead and download that. Okay, so we should have three files. Well, we should have these three files in our directory now. We've got the flag.txt file, the format string 0 file, and the format string 0.c file. So we're going to need to take a look at the format string 0.c file in order to understand which part of the program is vulnerable to buffer overflow. So let's go ahead and do that by examining the file with the nano text editor. So nano space format string 0.c. Okay, so this is another program over here, and you know what? Before we take a look at the source code, let's just run the file first and figure out what the program does normally. So we're going to do chmod +x on the name of the binary, format string 0, and then we're going to run the program. That's going to be / format string 0. So it says, we have a message over here. Welcome to the newly opened burger place, Pico and Patty. Can you help the picky customers find their favorite burger? Here comes the first customer, Patrick, who wants a giant bite. Please choose from the following burgers: breakfast burger, grilled cheese, bacon deluxe. So enter your recommendation. So it's looking for user input. So we could try copying one of these, breakfast burger, paste it in. Okay, Patrick is still hungry. Try to serve him something of a larger size. Okay, so this is basically the what the program does. And we'll take a look at the workings of the program by taking a look at the C source file. So nano format string 0.c. And immediately we see that there's some memory allocation over here. So buff size is equal to 32 and flag size is equal to 64. This is another file where we need to trigger the SIGSAG handler over here, basically crash the program to get our flag. So what is going on here? There's a certain function in this program that is also vulnerable and lets us overflow the buffer. So it's, which one are we looking at? I think we're looking for okay. We're looking at this function over here. So when it asks us to select what we want to serve to the customer, it uses this function right here, which is the scanf function. Let's talk about the scanf function for a little bit. MD Shamir Rahman Safat says, do you stream daily? I stream on Mondays, Wednesdays, and Fridays. Not every day, but I do stream 3 times a week. So let's talk about this function here. So we're taking a look at the scanf function in this exercise. And the scanf function is used to take in formatted user input and save it to a variable. So this is a little bit similar to the gets function that we hacked in the previous exercise, but this time it's going to take in a formatted string. So like the other functions discussed today, scanf does not check the size of the user input by default, so it can be used for buffer overflow hacks. So in this program, buff size is set to 32, and it is the allotted buffer size for the choice1 variable. So we're creating a variable called choice1 from the scanf function over here, and it's got a maximum buffer size equal to 32. So here, if the user inputs more than 32 bytes to the program, then a buffer overflow occurs. Okay, so before we solve the challenge, let's talk a little bit about program memory address space. So we've been playing around with memory address space for these challenges, and in order to study memory hacking further, we have to familiarize ourselves with program memory address space. So inside of the program memory, there are different sections, and first of all, at the very top, there's the kernel, then there's the stack section, the stack buffer section, the stack section, then you can put whatever buffers you want on that. Then there's the heap section, the data section, and the text section. So when a program launches, a portion of the computer's memory is allocated to it, forming the program's memory space. The data in the memory space is divided into chunks of 4 or 8 bytes for 32-bit and 64-bit programs, respectively. In a 32-bit program, the lowest memory address is 00000000. This is 4 bytes with 2 characters per byte, or hex 0000000, and the highest address is FFFFFFFF or hex FFFFFFFF. So the 0x that is prepended to the address indicates hexadecimal notation. There are 5 major divisions in the program. In the program memory space, that is the kernel, the stack, the heap, data, and text. So the kernel section occupies the lowest memory addresses and contains data related to the computer's operating system processes. So this is what is at the very beginning of the program memory space. The stack section follows the kernel section, and it contains variables that store program parameters. It is a prime candidate for buffer overflow attacks. As the data is added to the stack, it progresses to higher memory addresses, but any buffer overflows that occur on the stack progress towards lower memory addresses. So when the stack grows upwards, so there are 2 places where we can do buffer overflows, either the stack or the heap. And on the stack, the whatever is put into the stack, it goes up towards the kernel over here, and on the heap, it goes downwards towards the data and the text. Okay, so we're to learn. Let's go ahead and solve the challenge for that we started previously. So back in the web shell, we're going to take advantage of the scanf function over here. So the scanf function, it's going to save to choice 1, and choice 1 has a maximum buffer size of buff size. And we can see at the top of the code here, buff size is set to 32. So we should only need to send 36 bytes to the program before it crashes. And when it crashes, then it's going the program is going to print out the flag, and that's how we win. All right, so let's get out of here. Let's get out of nano. And let's run the format string 0 program. Okay, so remember, we have to, the buffer is 32 bytes large. We should send at least 36 bytes to crash the program. So let's go ahead and do that. So 1, 2, 3, that's 10. That's 20. That's 30, and then we're going to send 6 more. Okay, let's go ahead and send this this buffer overflow. And it says there's no such burger yet. Huh. I wonder what... So, okay. That should have worked if this is a 32-bit program, but there's a chance that this is a 64-bit program, in which case we would need to send more bytes. Let's let me use a tool to take a look at this binary here. Okay, so this is a 64-bit binary, so we need to send 4 more bytes. Okay, let's go ahead and do that. Okay, we're gonna run this. Let's see. So 36. We need to send 40 bytes. So that's 10. That's 20. That's 30. That's 40. Let's send just a little bit more. Let's send 6 more. No such burger yet. Let's see. CypherFreak says, "You're right. I just got it." Let's take a look at Okay, so it's the buffer size is set to 32. So Okay, let's just send a lot of bytes. Maybe we just need to send a lot of bytes. So 10, 20, 30, 40, 50, 60. How about 60 bytes? Okay, so if we send 60 bytes, then we get our flag. Sometimes we need to overflow the buffer by quite a bit in order to cause the crash. And that's because even though we're overflowing the buffer, sometimes the crash doesn't happen because we haven't overflowed enough into the buffer. But anyways, we got the flag with 60 bytes, and let's try sending this to the actual program to get the flag. So let's do that. So over here, we need to launch the instance. So format string 0, we need to click on the launch instance button. And then we need to copy this command over here. So this command is a netcat command, and we use the netcat command here to access the remote server that has the program running on it. We're going to go to our web shell. We're going to paste in the command, and then we can overflow the buffer here. I'm just going to copy this string over here because this worked on the test binary, and paste it in, and then we're going to hit enter, overflow the buffer. So it says PicoCTF, the customer is never seg fault. Nice. Okay, let's go ahead and copy the flag, and then go back to the challenge. In the challenge, at the bottom is the flag submission field. Paste in that flag, and then hit submit flag. And we're done. Okay. So there's one more challenge. We only have about 10 minutes to do this challenge. I'm pretty sure we can do it in 10 minutes. And let's just talk about it. Okay, so to learn more about buffer overflows, let's take a look at another challenge in PicoCTF. And I will provide this link to the chat. Cybernerd Dante says, butter overflow. And hello, peoples. Welcome to the stream, Cybernerd Dante. Why don't you have a good old hack the planet, and welcome to the stream.
Hack the planet! Hack the planet! Shut up and get in.
Okay, so this is the heap 0 challenge. So all of these challenges are very, very similar because we just need to overflow the buffer to get the flag and to finish the challenge. So it says our overflow is just a stack concern. So this is going to be a little bit different from the previous challenges because we're dealing with heap memory this time and not stack memory. But anyways, there's 2 links. What you need to do is you need to download both of these files here. And let me copy the links and download them to the web shell. So first of all, let me get rid of this format string stuff. And then we're going to use the wget command, paste in the file address. So the first one is downloaded, and we're going to download the second one. We use wget to download the second one. Okay, so one more time, we need to make sure that the binary is executable. We do that with the chmod +x command. So it's now executable, and we can go ahead and run the program normally. And when we run the program normally, it says, "Welcome to heap 0. I put my data on the heap, so it should be safe from any tampering. Since my data isn't on the stack, I'll even let you write whatever you want to the heap. I already took care of using malloc for you." And then we've got a couple of memory addresses. So we've got memory addresses that have the following information over here. So there's pico in one value in one memory address, and there's bico in the other. 8-Bit Bandit says, gotta go for a bit, back in about 20 minutes. Have fun, HackerFrogs. Hey, see you later, 8-Bit Bandit, and yeah. Thank you very much for coming by the stream. How about you have a Nyan Cat to see you out? Okay, so the program here has a few different functions. You can print the heap, so print the current state of the heap, which we need to overflow in order to finish the challenge. We can write to the buffer, which lets us write whatever we want to the heap. We can print the safe variable, and we'll be talking about the safe variable in just a little bit. And we can print the flag. Try to print the flag. Good luck. Okay, we're just going to get out of here, and we're going to take a look at the source code for this challenge. So let's take a look at shell.c with nano. And we see here that there are a few different buffers defined here. So there's input data size, and that's equal to 5 bytes. There's safe variable size, which is equal to 5 bytes. And what else? There's a win function over here. So check win, this is a function. So if string compare safe variable with the string pico, and it's not equal to 0, then it's going to print you win. So if the safe variable is not this word right here, pico, so not equal to 0, it's going to print you win, and then it's going to print the flag. And if there's no flag, it'll say, if there's if the safe variable is not pico, then it's going to print this. Looks like everything is still secure, no flag for you. Okay, and then we've got our menu function over here, which prints out all this stuff. And let's see, we've got this other function here that writes to the buffer. So in the write buffer function here, it's going to run scanf. And remember, scanf can be used for buffer overflows. So this is our way to do the buffer overflow by writing to the right, by using the write buffer function over here. All right, we got ads on Twitch. When ads are on Twitch, they're also on YouTube. And let's go ahead and play another bird video. How about this bird video? Okay, so we're going to be taking a little break for about a minute or so. Please enjoy the bird videos, and I'll be back in just a few seconds after I have a bit of water. So if anybody has any questions about any of the stuff that we've been learning today, please feel free to leave the comments in the chat. Comments or questions in the chat, and I'll try to answer your questions as best I can. I'm not especially an expert as far as binary hacking is concerned, but I am very curious and I am learning, and the stuff that I learn I like to teach, and I'm now teaching you guys. And if you've got any questions about any of this stuff, let me know. Okay, let's go ahead and put the birds away. They will be back later. All right, so what do we need to do to win? We need to overwrite the safe var variable. So we can see that the safe var variable is, let's see, where are we? The safe var variable is pico, and we need to overwrite it using a buffer overflow. So let's talk about the difference between stack up buffer overflows and heap buffer overflows. So what is heap memory? So heap memory is a section of program memory which holds variables that are intentionally allocated through C functions like malloc. So these are intentionally allocated variables, and they exist on the heap as opposed to the stack. So there are two sections that we can potentially utilize for buffer overflows. We've been utilizing the stack, but this time we're going to have to use the heap. And the difference between the stack and the heap is this. Buffer overflows that happen in heap memory are different from stack overflows in that they may use to overwrite the values of other program variables. And this is what we're going to need to do when we're overflowing the heap. We can actually access other stuff on other variables on the heap, and we can change the values of those variables. So here, if the program takes input Here, the program takes input using the scanf function, and 5 bytes are allocated to the memory buffer. So scanf is going to take your user input and it's going to save it to the heap. But there's only 5 bytes allocated to it, so that means that if we send more than 5 bytes, we're going to do some buffer overflow. The program also lets you see the memory addresses of the input data and safevar variables, respectively. So this is the address for the input data variable, and this is the memory address for the safevar variable over here. You'll notice that the memory addresses are actually not very far away from each other. So this is hex B and this is hex D. So the difference between these two should be about 32 bytes, because that's the difference between B and D in hex. So about 16 times 2, which is 32. So since the address of input data is lower than the address of safe variable, and they exist on the heap, we can overflow input data to overwrite the safe variable. So when you overwrite the input data, it's going to write, and then it's going to overwrite the safevar variable. And let's go ahead and demonstrate that. So we've got, okay. So in the web shell, we're going to get out of the web shell, and then we're going to run the shell program. Okay, so we know what we need to do to get the flag is we need to overwrite this variable right here. So what we can do is we can choose number 2, write to buffer. So 2, enter, and then data for buffer. We know that the difference between these two addresses is about 32 bytes. So first of all, we're going to send 32 bytes. So let's see. So that's 10. That's 20. That's 30. This is 32, and we need to overflow the buffer. Actually, I think we need to add the buffer to our string over here as well. So there should be 5 over here, because that's the allocated number for the input data buffer. So that's going to be 5, and this is 4. So let's just do 5 plus 4, 9. We'll send another 9 bytes. Okay. So let's send all this. And then afterwards, we've written to the buffer. Let's go ahead and print the heap. And we see we've overwritten the buffer for the safevar variable by about 9 characters here. Okay, so let's go ahead and print the flag, because if we print the flag and this variable is not Pico, then we get the flag. So number 4, print flag. You win, we got the flag. Awesome. Okay, let's solve the challenge for real now. So here in the heap 0 challenge, we're going to launch the instance. So I might be explaining things a little bit fast. If you find that I'm explaining things a little bit fast and there's some concept you don't quite understand because I've been talking quickly, please let me know, because I don't want anybody to feel like they're being left behind. I am trying to work through these challenges kind of quickly because I'm already running over time. Anyways, let's copy this netcat command over here. Then go over to the web shell. In the web shell, we'll paste in the command, and this is going to let us get access to the program on the remote server. Okay, so to finish the challenge, we need to write to the server. So we're going to select 2, and we're going to do data for the buffer. Let's do, what was it? 32? 32 plus 9. 32 plus 9 is 41. 32 plus 9. Okay, 41. Okay, let's send 41 bytes. Okay, that's 10, 20, 30, 40, and then 1 byte. The last byte will be A. We're going to write that, and then we're going to print print the heap. So number 1. We see that we successfully overwrote the safevar variable, so let's print the flag. Number 4. Okay, done. PicoCTF, my first heap overflow, great. Copy that. Then go back to the challenge. In the challenge flag submission field, paste in the flag, submit the flag. And we're done. All right, so everybody, that was binary hacking intro. The binary hacking intro session. So this is a course in progress. I'm trying to write a bunch of different lessons for binary hacking here. I hope you got something out of doing this workshop with me, and let me know in the comments in the chat if you learned something today. Anyways, we have to move on to our next piece of content today, and the next piece of content we're doing today is we're going to be talking about web app hacking. And the web app hacking we're going to be doing is we're going to be working against the challenges over at the Natas CTF lab. So if you've never used the Natas CTF labs over here, there are a bunch of different web app challenges, and each level in the challenge is going to give you the password for the next challenge. And we've been doing these for a while, and we've come up on level 14 over here. And for this part of the stream, we're going to put on some music because I like having some music on while we do our demonstration. So let me go ahead and pull up some music. How about some stuff from... Ooh, Baba Is You. You know, I'm considering playing some Baba Is You on the stream because it's a really great little puzzle game. And it really reminds me of hacking because, man, it's all about manipulating rules and knowing how to pull off little tricks. And it really reminds me of creative hacking. Okay. So if you feel like the music is too loud, let me know, and I'll try to lower the volume. Actually, I think I might lower the volume a little bit now. The music should be in the background. It shouldn't be too loud. So I'm just going to reduce the volume of the music. If you find the music's too loud, let us know and we will adjust the volume. Okay, so let's go ahead and access the level that we're going to do the demonstration for. That's going to be level 14. So, done with this. So we keep track of all of our solves for these over the wire challenges. So we got one for Natas over here, and if you want to take a look at the solve methods for the different levels of the Natas challenge that we've done so far, you can access it from this GitHub page over here. So let's go ahead and go to level 14. Okay, if you want to play along with us, this is the username, and this is the password we're going to be using. And I'm going to access natas14.natas.labs.overthewire.org. Okay, so everybody, this is the webpage we're taking a look at. If you want to join in, you can go to the webpage. You can use the credentials that we just left in chat. Let me grab that password. So this is Natas level 14. You're going to need to input the username as Natas14, and the password, you're going to need to paste that in, and then click on sign in. Okay, so let me make sure that Oh. You know what? We've already done level 14. I just remembered. We're on level 15. Sorry about that. We're doing levels 15 and 16 today. So let me get the password for the next level. So it's Natas 15. This is the password. And we're going to need to access Natas 15 at this webpage. Okay. All the links are in the chat. Username is Natas15. Password is the password. Copy and paste. Sign in. Okay, so what is going on in this application? Let's go ahead and test out the application first. So it says username. So we don't know about any usernames. For most of these challenges, we've been dealing with usernames like Natas something something, like Natas 15 or Natas 14, Natas 17. Let's go ahead and check Natas 15. And it says this user doesn't exist. Okay, we can go back and we can check Natas 16 and see if Natas 16 exists. Check existence. This user exists. All right, so we're dealing with more SQL vulnerabilities in this case, and let's go ahead and view the source code for the application. So one of the nice things about these challenges is that you can take a look at the source code that was used to create the application. It's going to give you a very heavy clue as to how you need to solve the challenge. So we can go ahead and put the source code in a new tab. Okay, so what do we have here? It says here, well, first of all, we should take note that this is PHP code, and we can tell because there's a PHP opening tag and a PHP ending tag at the beginning and ending of the code over here. But what is going on in this code? So first of all, it says create table users. So we know that inside of the database, there's going to be a users table, and in the users table, there's a username column and a password column. This is going to be important for later. So what do we have in the code? So if array key exists, username request. So if we send a request with the username, then we're going to create a link variable, and the link variable is going to be the MySQL connect function, which is going to locate the localhost database. I'm pretty sure this is the name of the database. This is the name of the user, and this is the name of the password, but the password's not here because it's censored. And then we're going to run this function. This is going to be MySQL select DB. Oh, select database. Okay, so it's going to select the database, Natas 15, and it's going to run a query. The query, the SQL query that we're using right here, is select star from usernames, where username something something request username. If array key exists, then it's going to echo executing query, and it's going to either send back one of two messages. So if the number of rows that are returned is 0 or less, it's going to say, oh, it's more than 0. Sorry, this is greater than. So if the response is more than one row, it's going to say it's 0 or more. It's going to say this user exists. Otherwise, it's going to echo this user doesn't exist, or error in query. Okay, so what we need to do here is we need to take advantage of the SQL query, the statement that's being run, and we're going to be doing a little bit of injection in this case. So this is what is called Boolean injection. Boolean injection because we're going to get one of two results from the system. The system is either going to send this user exists, which means it's a true statement, or this user doesn't exist, which is a false statement. So let's go ahead and go back to the application. So the application here, we know that Natas16 is going to return true. This does exist in the system. Check existence, this user exists, true. Okay, so what we can do is we can try to escape the statement that's being used in this case. And to escape the statement, we need to know what kind of quotes are being used inside the statement. So we know that the statement is this, and we see that it uses double quotes over here. So we can use the double quotes to escape the statement and then start doing our SQL injection. So we do double quotes. So double quotes shouldn't break anything. It should still... Oh, error in query. Okay. I think I know the reason why. So we need to send something else in the query. So we can send or1 equals 1 and then quote out everything else. This user exists. Okay. So what we're going to do is we're going to craft a payload that's going to give us the password for the user. And this is what we're going to do. So I've got a little payload over here. And we're identifying that the SQL query will either return true or false, then craft an SQL payload, which will return true or false and indicate the name of a valid user, Natas16. So what we want to do is we want to leak out the password by adding this substring over here. So we're trying to get the valid characters in the password, and let me demonstrate what this looks like if we're just starting out. So this is the name of the user and something something. Copy this. We're trying to get the password for the Natas16 user. So for example, we could try to determine if the password starts with the letter A. So the substring function over here, it's basically going to return part of a string, and in this case it's going to return part of the string of the password. So the first character, starting at the first character, ending at the first character, we're going to look for the letter A. If this returns true, that means that the password starts with the letter A. You check the existence, it says the user doesn't exist. That's because it doesn't start with the letter A. So we can start iterating over this. We can try B and see if the first letter is B, and I think the first letter is actually H. So if you check here, this user exists. So we got the correct first character. The problem with doing SQL injection like this, where we're trying to iterate through a bunch of characters, is that it's very slow and very tedious, and that's why we invented scripting in order to do this in a programmatic way. So once we finish guessing the first character, we can actually guess the second character by adding on to this H over here. So I think the second character is capital K. Check the existence of that, doesn't exist. Let me look back. So over here, so the next letter is P. So we can do HP like this. So first letter starting with the first character, ending with the second character. HP, check the existence. This user exists. Okay, so what we're going to do is we're going to use a script to automate this process. Because if you do this all completely manually, and you're actually going through each one of the letters from from A to Z and all the letters, it's going to take you a really long time, maybe a couple hours or something, just to get the password for the next level. So we're going to use this script over here. So we can use the following script to brute force the password. If you're wondering where I'm getting the script, it's located over at this link. I'm just going to copy the script, and before we run the script, we'll go over exactly what's going on inside the code. Okay, so back here, we're going to nano and create a file called natas15.py. Okay, and then we're going to paste in the code. Okay, so there's a bunch of stuff going on in here. This is actually not as long a script as some of the other scripts that we use for solving the Natas challenges. But let's talk about what's going on inside the script. So we need to import 2 different libraries, or 2 different modules to run the script. So this is the request script, and the request script is used for doing web requests, and the string module. And the string module is used for doing manipulation of strings. So the first thing we need to do is we need to set some variables here. So we need to set the URL that we're going to contact, which is Natas15, the index page here. We need to send some. So remember that we logged into the page when we first accessed it. So we need to send our credentials here. So Natas15 on our password, this one over here. And then we need to send some characters to test. So the characters to test is going to be all the numbers and letters that we want to iterate through. And we're going to set the character set variable, and it's going to be equal to the string module ASCII letters plus digits. So basically all the letters in the ASCII encoding scheme and the number 0 to 9. Okay, so storage for the extracted password. We need to store our password as it's being leaked out, and we're just going to set it as an empty string, but this is going to get populated as we run the script. Okay, so the next thing we're going to need to do is we need to set up some the session. So whatever session we're going to establish it in order to access the web page. So session equals request.session. Session authorization is going to be username and password. So we're going to print out starting password extraction. We know that the password is 32 characters from previous levels. So all the previous levels in the Natas game have had passwords of 32 characters in length. So this is the loop that we're going to run. The loop we run is for position in range 1 to 33 for character and character set. This is going to be the payload. So the payload is going to be the SQL injection payload. So Natas16, and then we're going to send the substring password position 1 equals character, and then the rest of the SQL payload over here. We're going to send this request as a post request with our URL and our data equal to the payload. Next, we're going to check if this user exists is in the response, because if it responds this user exists, that's going to be a hit. And we want to, each time there's a hit, we want to record that character and then add it to the extracted password. So check if the character is correct. So remember, we have to check for true or false. If it's true, then that's the part of the password. If it's false, then it's not. So if we didn't find a password, shouldn't happen, then we couldn't find a character at the position, and then break. Then we're going to print completed password is going to be this. So this actually stops after we run through all of the characters in the range, which is 1 to 33, which is actually 32 characters. So after we find this 32nd character in the password, we're going to exit from the script. Let's go ahead and run the script. I'm going to save this out. And then we're going to run the natas15.py script. So Python natas15.py. So this is going to take a little while. So it finds the first character, then it finds the second character, the third character, the fourth character, etc., etc. So this is going to take a couple of minutes because it has to work through 32 characters. But eventually it's going to leak out the entire password. So we don't necessarily need to I guess we could watch the script running, and if you have any questions about anything that we've done so far, please let us know in the chat. I'm happy to answer any questions. It doesn't necessarily have to be about this challenge, but I can't get too distracted because I've got a couple of levels to demonstrate over here. Okay, we're about halfway through.
Hide the planet! Hide the planet! Shut up again!
CypherFreak on Twitch asks, what was the particular vulnerability here? So the vulnerability here is what is called a blind SQL vulnerability, and it's also a Boolean-based SQL vulnerability. So it's called blind because we don't see the exact response from the server. We only get true or false, and because we can determine if a statement is true or false from the system, that's called a Boolean-based vulnerability. So Boolean-based means it either the system will respond true or false. So this is a blind Boolean-based SQL injection. Okay, let's go back to, oh, we got it. Okay, so we finished our characters and we leaked out the entire password. So this is the password for the next level. I'll just paste it into the chat in case anybody wants to take a look. So the next level is actually a little bit more difficult than the one that we did today for this one. But let's go back. Okay, so we got the password for Natas level 16. And let's go ahead and access that level. So it's Natas level 16. Username is Natas16. Password is this. And sign in. Okay, we've got an ad running on Twitch. So we're going to do an ad on YouTube as well. And we're going to show some birds. Actually, before I show some birds, let me copy that password one more time for Natas16. Because I think... Did I copy this incorrectly? Hold on. Natas16. I'm not sure why the password isn't working. Let me double check my password. Okay, so it's Natas16. Probably contains white spaces. Yeah, No, okay. I think the problem was that the address was incorrect. So this is the correct address. I tagged on the index.php, and I think this page might not be called index.php. I think that's why it didn't work. Okay, everybody, I'm going to take a little water break. I'll be back in a couple seconds. Okay, so it says here, for security reasons, we filter on even more on certain characters. So this is actually a repeat of it's a more difficult version of the OS command injection lab that we did in an earlier level. So if we send test, then we get a bunch of grep output. So what's happening on this level? So if you want to participate yourself, then I've left the Natas16 username and password in the chat, as well as the URL over there. You can use that to log in. So because we are given some source code over here, we should probably take a look at the source code. It'll give us a good hint as to how to proceed. So we're going to put this in another tab. And the code is actually very short. So this is some PHP code again. So the PHP code here, it's there's an empty variable called key. So if array key exists needle request, then the key is going to be equal to the value for needle. The needle is whatever user input that we send. So the next portion of the code says if key is not empty, if it doesn't contain any of these characters over here. And we're not supposed to bypass this filter. It took a really long time for us to figure out that we can't bypass this filter. But these are the illegal characters, and we can't use any of these to do the hack, because it's going to print input contains an illegal character, but otherwise it's going to run this function right here, pass through, and pass through is going to run a system command. The system command that is going to run on the server is going to be the Linux grep command on dictionary.txt. So this is all mandatory. We have to run grep-i, and we need to run it on dictionary.txt. And whatever is in the middle here, this is our user input that we need to manipulate to get OS command injection. So how do we solve this? So after some, let's take a look at the walkthrough. So this is my walkthrough, by the way. I'm not looking at somebody else's random walkthrough, but I did get some help to solve this level. So what is the web vulnerability here? So in this case, what is actually happening is blind OS command injection. This is actually this kind of blind OS command injection vulnerability. I never really considered it before this level, which was a couple of weeks ago. So I am learning a lot. So the method of solve, what are we doing here? We have to figure out that we can use the $ parentheses syntax to output the result of a command. For example, we could do this. And we know that there is the password for the next level inside the etc Natas webpass directory over here. Thank you very much for following, Luck Dominguez. Luck Dominguez, thank you very much for following. Have a hack the planet on me. You're now HackerFrog.
Hack the planet! Hack the planet! Shut up again!
Okay, so if we run the grep-e, well, okay, what's happening here? We're trying to run another grep command inside of the grep command. So we're trying to grep inside of this Natas 17 password file. So the Natas 17 password file, we want to gradually leak out the password for this. We need to gradually leak out the password for Natas 17, and the first thing we need to do is we need to grep the letter E. Well, we don't need to grep the letter E, we need to grep out something. This is the pattern. I think it's grep E because the password does have the letter E in it. So we can go ahead and experiment with this. So over here in the web app, we're going to send this payload. So the payload is inside the $. So what does this command do? So it basically $ and then parentheses. This is going to be the result of a command. It's going to be the output result of a command. And in this case, it's going to be grep E on etc Natas password Natas 17. If we run this, nothing happens. And nothing happens is actually what we want to look out for. Because if we send a letter that is not in the password, then we get the entire dictionary.txt file. So this is how we determine if we found a correct letter for the password. So this is another blind injection. It's another blind injection. This time it's not an SQL injection. It's an OS command injection. So we see here that that E is correct, because when we send E, there's nothing that is output. But the next thing we need to do is we need to check the next character. So the next character we would send maybe the next letter, EA. Is there an EA? There's no EA. Okay. And then we would do EB, EC, etc., etc. Cyberfreak asks, why were you getting unauthorized when logging in? That's because I was sending the wrong endpoint. So I was trying to access index.php. Huh. You know what? I don't know why I was getting unauthorized before, because this is index.php. There's something, I guess I wasn't able to access it before. Let's see, index.php. Let me try sending this to a private window. So it's going to ask me to sign in. Let's try signing in with Natas16 and the password. Let me grab the password. Yeah, this doesn't work because I wasn't accessing the landing page. So it only lets you log in initially if you're accessing the landing page. So if I change this from index.php to nothing, then it'll let me log in. Oh. Come on. Sorry, I'm getting a little bit distracted. Yeah, I'm not too sure why this one was unauthorized. Anyways, let's go ahead and talk about how we're going to be solving this. Let me so first of all, I need to find out what the actual password is, so I can demonstrate. Okay, EQ. Okay, so this is what we do. We would keep on iterating for different characters in the password. So for example, if we were to send EQ, it's not going to send any output, which means we hit on a unsuccessful second character. So doing this for all 36 characters is not the way to go. So we have to do we have to write up a little exploit. Sorry, a little hacking script, and this is the way we do it. Where was it? This is for 16. So we're looking for responses that don't return anything. This is our true statement. If an incorrect character is appended, then the entire dictionary is returned. So we can use the script below to automate the blind OS injection process, OS command injection process. So if you're wondering which script we're looking at here, we're looking at this one. So I'm just going to copy that, and then I'm going to create the script. So the script is going to be, this is a Python script. It's going to be natas16.py. Okay. Well, no. It's not. We need to use nano to edit the script. Okay, paste in the clipboard. And before we run the script, let's talk about what's happening inside this hacking script. So this is a Python script. We're going to import the requests module. We're going to yeah, we're going to use the basic auth function from the request library. We're going to set the URL that we're going to access, which is natas16.labs.overthewire.org, and then we're going to send the needle. The needle is the parameter. In this case, we're going to set S as the session, and the authorization for the session is going to be the basic auth. So that's natas16 and the password. So the password file 17, I guess, is going to be the password location, which is etc natas webpass natas17, and we're going to send the prefix tested over here. We're going to set up a get password characters function, so filtered, we've filtered these, whatever, so the filtered list is going to gradually be populated with our characters over here. So these are the characters that are involved, lowercase a to z, uppercase a to z, and numbers 0 to 9. We're going to print this message looking for password character set for character in characters. So this is the loop that's going to get the password letters for us, characters rather. Input text is going to be, this is the grep command from our payload. So grep this character from the password file. So basically this is the payload we're sending. And if we find a hit, then we're going to filter out the character. We're going to add it to the list. The password contains something something. So whatever parts of the password that we managed to leak out, those are going to be gradually added to the complete password. And at the very end, we're going to return filtered, which should be the entire password. So there's another function over here, get password. Looks like this, okay. So step 1 is to find out what characters the password contains, which is running this function here. Step 2 is to find out the password by ordering the characters found in step 1. The password is this. So whatever characters are included, we're going to try to find the correct order in the second step. So let's go ahead and save this out, and then run the script. Okay, so this isn't. These are the characters. The character contains these characters. This is not the order of the password. It's the next section which looks for the order of the passwords. So it finds the order of the passwords here, E, Q, something something, and it's got to find 32 positions because the passwords are 32 characters long. So this is going to take a little bit to finish, so if anybody has any questions about what we're doing here, or any questions about web app hacking or about cybersecurity in general, let us know in the chat, and we'll try to answer your questions as best we can, because we got to wait for another minute or so. But actually, it's not going to take, it doesn't look like it's going to take too long. So, should be coming back in the next 10 seconds or so. Okay, so this is the password. The first thing that the script did was it determined what characters were in the password. And the second thing it did was to figure out which order the password characters were in. So this is the password for the next level. So we might have time to do the next level depending on how much, how complicated the level is. I'll need to take a look at that in just a little bit. So for everybody who's keeping track at home, this is the password for Natas 18. What level is this? This is now level 17. Okay. So let me just take a quick look at. So we let's prove that this is the password for Natas level 17. I'll just grab the password, copy it. Then let's try to access Natas level 17. Okay, then the username is Natas 17. The password is this. It looks like the next one. Is this another case of? This looks very, very similar to Natas 15. So in this case, we would look for Natas 18. It doesn't give us anything. Oh, right. This was this was the time-based one. The the time, yeah. Okay. So we don't have enough time to do the next level because the next level is kind of complicated. But let's go back to our walkthrough over here. Let me do a quick look at level 17. Okay. So this one is a SQL injection, blind time-based injection. So this is the other type of common blind SQL injection, where you don't get any response from the application, but if you're able to send a true SQL injection payload, then you can make the program sleep and take longer to respond, and that's how you determine what is a correct statement and what is a false statement. Yeah, okay. If you're interested in taking a look at it immediately, then you can go ahead and do it at this link over here. What we're going to be doing now is we're going to be shifting over into the next section of today's stream. And the next section of today's stream is Natas CTF levels that we haven't solved yet. And these might be really painful. 8-Bit Bandit says, I am back. Hello, 8-Bit Bandit, nice to see you here. Let's go ahead and welcome you back with the Hack the Planet.
Hack the planet! Hack the planet!
Okay, so we're going to be starting our challenges with level 19. So I started doing level 19. I think I did a couple of levels off stream, and I think I did level 18. Level 18 was Insecure Session Management. This was actually maybe I can demonstrate this one. So what happens in level 18? In level 18, the application only uses integers in its session ID creation, and the valid session ID numbers range from the numbers 1 to 640. Let's go ahead and take a look at level 18. Let me give you the password so that we can all take a look at it. Natas 18. Okay. Natas 18. Whoops. Password is this. Okay, so it says here, please log in with your admin account to retrieve credentials for Natas 19. So you give a username and you give a password. So we can do, actually, well, I don't know. Are we admin? Maybe. Send a password over here. Log in. It says you're logged in as a regular user. Log in as an admin to retrieve credentials for Natas 19. Okay, so we actually see the source code is the key for solving this challenge here. Let's go ahead and take a look at the source code. So how much, let's see. I got enough music for the next few minutes, and then we'll change to some other music. Okay, so what's going on in the PHP code for this level? So we've got a variable called max ID. So max ID is equal to this integer 640. It says 640 should be enough for everybody. Okay, we got a function that says is valid admin login. Request username equals admin. That says this method of authentication appears to be unsafe, has been disabled for now. So we can actually, this function doesn't work. But we've got some other functions over here, such as function is valid ID on ID. And what is the ID? What is the ID variable set to? Return is numeric ID. So another function here is create ID for user. So global max ID. So global, it's being set as the max ID, and we know that the max ID is 640. Return random 1 to max ID. So it's setting up a random number between 1 and 640 with this with this function here, rand. I think the debug function doesn't, I don't think it works, but we need to pay attention to this function right here, because this is the function that creates the session. So the function is mySessionStart, if array key exists, PSSS PHP session ID cookie, and is valid, cookie PHSS sesh ID. If there is no session start, debug session start failed. Otherwise, session start okay. If there is no key, admin session, session was old, admin flag set. Session equals admin 0. Actually, wait, session start. I don't think. Hold on. Okay. I think this is the actual function that we need to pay attention to. Let's see. This is the function here that creates the cookie that is valid. So if array key exists, user name request, and array key exists, password request, session ID, create ID, request username, session start. So if session, they're gonna check if we're a valid admin by checking the session number. So this is what we need to do. If we take a look at our regular user, we can take a look at the cookies by going over to More Tools in the web browser and go to Web Developer Tools. And we're going to see that the PHP session ID is a flat number. So this is 222. So the application is actually checking the value of your cookie to determine if you're an admin user or not. Arushan Myth says, "What's up?" What's up, Arushan Myth? Nice to see you here. Why don't you have a Nancat? Welcome to the stream. Okay, so so this is actually a lot easier than some of the other levels in the Natas game, because we're basically iterating through valid cookie values. So PHP session ID is going to be a value between 1 and 640, and the different cookie values are going to give you different levels of access. There's one cookie that's going to give you admin access to the application, and that means we can brute force this. So the way we're going to brute force this, we've got another Python script that's going to try to access the application with every single possible version of PHP session ID. So it's going to be over in the write-up. Where are we? Here. So the application uses only integers in its session ID creation, and the valid session ID numbers only range from 1 to 640, which makes valid session IDs vulnerable to brute force attack. We can brute force a valid session ID in a few different ways. Here's the Python method. So we could do this brute forcing with a few different tools. We're just going to use Python in this case. It's not a very long script. So let's go ahead and write the script and solve the level. Oh, sorry everybody. If you want to take a look at this script in the write-up, it's at this link. Okay, this is going to be for Natas 18. Let's paste in the code. So it's not very long code, but we do import the request library because we need to supply some session ID variables here. So we've got the URL over here, which is natas18 index.php, and we've got our basic auth credentials here, natas18 and our password. So we need to we need to try to access the page multiple times. So for session ID in range 1 and then 641, which is actually 640 attempts. For each attempt, the cookie is going to be PHP session ID, and we're going to send the number of the session ID in the form of a string. And in the response, we're going to get from the URL, we're going to get the response from this request over here. And we need to look for this message inside the response text. So you are an admin, and in that case we're going to print that we found the admin session with this cookie number, and then we're going to print out the response text, and we're going to break out of the loop. Okay, let's go ahead and run the script. So we're just going to save out the script, and then we're going to run the natas18.py script. So an important thing to note here is that we're going to try to log in with every single cookie number to figure out which cookie number will get us admin access. So this script doesn't show us a lot of output as the script is running, but eventually we're going to run across the correct one. But we've got an ad running on, it's going to be run on Twitch pretty soon, and by the time the ads are over, we should have a response. So we should have rewrote the script to be a little bit more interactive, or a little bit more, so maybe something like trying session something something, and then, and then afterwards it'll give us the correct result. Okay, we got ads running on Twitch, so ads will also run on YouTube, and let's go ahead and put on a bird video. Okay, I'm going to take a little water break. We'll be back in about a minute. Okay, I think I'm going to take this opportunity to change out the music, and I'll play one of my favorite soundtracks, which is the... Actually, let's play some cyberpunk music from the Valhalla game. Okay, let's play that music. We'll be back in about 20 seconds. This little bird is so entertaining to watch. Okay, let's put away the birds and let's finish off this this level. Okay, so eventually we found the admin session for the valid cookie value. So it's going to be PHP session ID 119. So after that, we get the credentials and the password. So username Natas19, password this. So to everybody keeping track back home, this is the username password. Natas19, this password, and let's start the first of the levels that we haven't solved yet. Okay, so this is level 19. We have not solved this. I started looking at the level, and I figured I should probably solve this on stream, but you'll see what exactly is going on after we access the level. So let's go ahead and do that. So let's see. So the level is Natas19. The username is Natas19. And let me get the URL for everybody, just in case. you need it. Okay, so Natas 19 password. Did I copy the correct password? This is 19, right? Copy that. Okay. Alright, so this page uses mostly the same code as the previous level, but the session IDs are no longer sequential. So we'll talk about what's going on here in just a second. So it says, please log in with your admin account to retrieve credentials for Natas 20. So we've got a username and password field over here. Let's just try test. Let's try test. Try logging in. So it says you're logged in as a regular user. Log in as an admin to retrieve credentials for Natas 19. So the important thing that we have to take away from here is that the method of solving the level is not as easy as the previous one, because it says the session IDs are no longer sequential. So we'll see what that means in just a little bit. So like in the previous level, we can go ahead and go to the web developer tools, and we can take a look at the PHP session ID. So we have to note that, can we make this smaller? Okay. I can't get the value of the whole cookie. Okay. So the PHP session ID is now what looks like some sort of hexadecimal number here. So we probably want to examine this cookie to see how it's different. So this is the cookie here. So 323939. So this is a hexadecimal number. It's probably. So what we're going to do is we're going to try to see if we can decode this somehow. If there's some sort of encoding method that's happening. So I'm just going to copy this. Then I'm going to go to a website. Maybe we're going to go to. We're going to look for hexadecimal to ASCII to see if we can convert this from hexadecimal strings to ASCII. So we're just going to paste this in. If anybody's wondering what website I'm using, it's this one. And then we're going to convert this. And it looks like the username is included in the cookie. So my guess is that we have to manipulate the cookie so that it uses a number, and I think it's probably still using the numbers from 1 to 640, but they're just appending a dash and the name of the user to the end. So this is what I have so far for this level. So the web vulnerability in this case is insecure session management, and the previous level the vulnerability was also insecure session management. So what do we think we need to do here? So it looks like this app is still using the same method of assigning session IDs to be used as cookies, but a dash and the name of the user is appended. So a random admin logon might look like this. So you log on as admin, but you also get a number and a dash. So the cookie is then encoded from ASCII to hexadecimal. So the resulting cookie is a hex string. So what we need to do is we run the same script as the last level, but after generating the number in the range, we prepend it to this string over here, -admin, and then we convert it to hexadecimal before sending each request. Okay, so we need to adjust our script. So what we're going to do is we're going to copy the script over here first. I'm going to copy this. We're going to call it the Natas 19 script. And then let's go in there. So what are we going to do? So the authorization is going to be different, and the URL is going to be different as well, because we're not doing Natas level 18, it's level 19. So 19, Natas 19, we need to switch out the password, because the password is different now. Let me grab that password. Paste it in, paste it in. Okay. Alright, so for session ID in range 1 to 641, the cookie is going to be ph session ID and then the string. Okay, this is going to be different. So we need to do the transformation first. So the cookie is going to be session ID, and let's make a new variable called encoded session ID. So we need to transform it. Encoded session ID is going to be equal to session ID, and then we're going to add something to it. Actually, maybe we should do this in steps first. So encoded session ID is going to come later. The first thing we need to do is we're going to do the formatted session ID, and the formatted session ID is going to be equal to session ID, and that's going to be the number. So I guess it's going to be the string of session ID, and we're going to add something else to it. So plus, and I guess let's do, so the session ID number plus this string over here, so admin. So I'm guessing that this is going to be the value of the cookie. We need to do the admin cookie plus one of these session numbers. And then the encoded session ID is going to be the formatted session ID, but we also need to do something to it. We need to encode it into from ASCII to hexadecimal. So I need to look up how to do that. Let me try asking the AI over here. So in Python, I want to convert an ASCII string to a hexadecimal string. What function should I use? So if anybody knows how to do this in Python just offhand, let me know, because I can appreciate I'd appreciate the help. Okay, so let's see. We've got a couple of methods. We can use the hex function or the encode function with hex. So use encode with hex, ASCII string equals this, hex string equals ASCII string.encode. Oh, encode UTF-8 hex. Yeah, this looks like it works. So, the .encode. Okay. .encode to hex. Let's go ahead and try this one. Okay, so formatted ID, session ID, .encode, UTF-8, hex, and then let's send the string version of encoded session ID. Okay, so hopefully this works. If it doesn't work, we're going to have to do some debugging. And what I want to do is I want to I want to print out the cookie that's being used. So we're going to print current cookie, and then let's print out the cookie. Yeah, just like this. Okay, let's try saving out the script. Let's try running it. See if it works. Python natas19.py. Oh, looks like clothing parenthesis does not match opening parenthesis. What have I... Oh, I added an extra parentheses there. Okay. The code doesn't work the first time. Okay, get rid of that extra parentheses. Okay, let's try running the script. Okay, so these requests are not super fast, but let's see. Let's see if this works. If it doesn't work, we're going to need to change out the script a little bit. Actually, you know what? What I want to do is I want to see the value of the unencoded cookie. So the encoded session ID. Let's take a look at the formatted session ID. So print current session ID. Oops, this is supposed to be an F string. Formatted session ID. And we'll get rid of the current cookie, because we know that the cookies are being encoded properly. Okay. Okay, so we're just adding the number. We're putting whatever number that we're iterating through, and then we're adding it to the... Oh, you know what? We do need the actual cookie, because we're going to be we're going to have to use the cookie to get the answer. Actually, no, we don't. Never mind, everybody. Jeez. I'm sorry that I keep on flip-flopping on this. Let's just run the script. So this'll take a while. It went up to I think it went up to 170 before we found the answer last time. It might take longer because it might be one of the later ID numbers. But anyways, let's take a look at our notes over here. I'm going to start writing up the finalized version of the write-up here. So this is for level 19. So what else could we do today? I think another thing that we could do today is I think we're okay talking about the PicoCTF 2025 challenges, because they've already announced the winners. So PicoCTF is a great event that I like to do each year, and let's see what their Twitter looks like. Hold on. Twitter, PicoCTF. Okay, so they announced the middle school winners, and they announced the other users, the other winners. So I think we're okay talking about write-ups now. I think I also saw some write-ups in the Discord thread, in the Discord for PicoCTF. So I think we're okay talking about write-ups now. Oh, okay, we found it. Okay, so this is Natas19. So you are an admin. The credentials for the next level are this. Okay, so this is it. this is the password for Natas level 20. So to anybody who's keeping score, this is Natas 20, this is the password. Let me go ahead and do the write-up over here. This is for Natas level 20. Okay, so username is Natas20. Password is the thing I just got. And we'll see what vulnerability is there in just a little bit. Let's commit these changes. Okay. So what? So PHP session ID 281. PHP session ID 281 admin. So let me copy this. This is just to make sure that this is the correct one. So we're going to go over to the website here. We're going to do text to hexadecimal. Text to hexadecimal. We're going to drop in this, and we're going to convert it. Okay, so this is the conversion. It's not exactly the right format, but that's fine. Let's format it over here. We just need to remove the spaces. Okay, so this should be the correct cookie value. Just going to copy this, and then we're going to go back to the web app, and we're going to replace our cookie in the web browser. Okay, PHP session ID. We're going to erase it, paste in the cookie value we have here. Thank you very much for following Cybe on Bush. Cybe on Bush, thank you. You are now HackerFrog. Why don't we give you a Hack the Planet? Just for being you.
Hack the planet! Hack the planet!
Okay, let's reload the page now that we've set our new cookie. Huh, we weren't logged in as an admin. What's wrong here? Okay, let's paste in that cookie again. Reload. I wonder what went wrong. You know what? I'm gonna rerun the script just to get the encrypted version of the cookie. Cybe Bush asks, "Are you participating in any CTFs?" Not currently. The last CTF we did was the PicoCTF 2025 CTF. Hold on. Okay, so we're not going to print current session ID. Instead, we're going to print the encoded session ID. So let's see, print fstring current cookie encoded session ID. Okay. Let's run the script again. So this is what the cookie looks like. So we're just gonna leave this over a little bit. I think it shouldn't take too long. I think it was what was the number? What was that number? Hold on. The number was 281. Okay. Well, we need to wait a little bit. But in the meantime, we're gonna finish off our write-up. I just need to paste in the code. So cat natas19.py. And let's go ahead and put this in our write-up. This is for 19. Okay, so this script should do the job. Paste in the script. Okay. And let's commit our changes. Okay, in the meantime, we can move on to Natas level 20. And this is the landing page over here. Actually, I want to. We'll do this in another tab because I still want to check that the cookie value is correct in that other tab. Okay, so this is Natas level 20, and let me get the password. Paste, sign in. Okay, so what is this? Is this still cookie stuff? It looks like it's still cookie stuff. You're logged in as a regular user. Log in as an admin to retrieve the credentials for Natas level 1. Your name. Huh. So, my name. Let's set our name to admin. We changed our name, right? And we've got source code for the application this time. So we can take a look at the source code. Before we do that, I'm just going to check on the script progress over here. Here we go. So this is the cookie. Is this the same cookie that we got from the website? I don't think so. Anyways, let's change our cookie here. Delete the cookie, paste in the new cookie, set the cookie, refresh the page. Yeah, okay, so that was the correct cookie, and we did get the password for Natas 20. Alright, let's, okay, so we're done with Natas level 19. Let's go ahead and take a look at what's going on in this app. So what I'm tempted to do first is take a look at our cookie value and see if it is the same, well, if it's some sort of transformation first. So let's go ahead and go to our web developer tools. Okay, now the session ID looks like this. Let me copy that. Okay, so what is this? This doesn't look like hexadecimal. So this is some sort of encoding scheme, but I'm not too sure what kind of encoding scheme this might be. Is it base 64? It doesn't look quite like base 64. So I can check to see if it's base 64 like this. So it doesn't look like base 64. So you know what we're going to do? We're going to check in with our favorite AI, and we're going to ask what kind of encoding this could be. If you recognize what kind of coding this could be, let us know in the chat or in the comments, and we would really appreciate it. Okay, so Mr. AI, what kind of encoding scheme could be at work here? Okay, so this is not hexadecimal, not standard hex. Base 32, not base 32, not base 64, base 58, possible base 58. So it could be a mix of numbers and letters for obfuscation. If not a standard encoding, it could be a custom ID or hash. ASCII representation, no, that's probably not it. Attempt base 58 decoding. Base 58 decoding, interesting. So if 26 characters long, it should be a hash value. If alphanumeric with no pattern, it could be a database key identifier. Most likely scenarios: custom identifier, modified partial encoding, stripped base 64, non-encoding use. So, okay, we actually have the whole application. We have the application source code, so we should probably look at that. Okay, what is going on in the code? So we need to figure out how they're encoding these cookies. Oh, what? So they're reading in session IDs. So session IDs. Data contains a serialized version of session, but our encoding is better. Make sure that SID is alphanumeric only. If it is not the length of the string length of session ID, return invalid session ID. My destroy. So this is. How's it being transformed? They're running this function on it. So string SPN. I don't know what this function is, so we should probably figure out what it is. So we can go to Google. Let's see, this is PHP. Okay, so what does the PHP documentation say? Oh, we got ads running on Twitch. When ads run on Twitch, we also do ads on YouTube. And let's go ahead and run a fun bird video. How about this fun bird video? Oh, yeah. That's a happy bird. Okay. This bird here is digging through the peanuts, and we'll be right back in a second or two. I just need to get some water. Just a sec. So it's actually kind of rare to see the birds actually eating the peanuts up by the bird feeder, but you'll notice. Hold on, where's my? You'll notice over here it grabs a peanut, and then it starts eating the peanut. So it just holds the peanut in between its little claws, and it starts pecking away at the peanut, and then it starts digging through the peanuts and finding good ones, and then it flies away. Okay, let's get back to the hacking. Okay, str SPN. So SPN is what? Finds the length of initial segment of the string consisting entirely of characters contained within a given mask. So what does SPN stand for? Finds the length of the initial segment of the string that contains only characters from characters. So let's go back. So it's looking inside of this variable here. Service principal name. Service principal name. That's something that I know from Windows from Windows Active Directory. It couldn't be the same thing, could it? Or maybe it's some other. It's like a similar concept that they use inside of Windows Active Directory. But yeah, so it looks inside this variable here, the SID, and then it looks at, what was it? What is this here? Finds the length of the initial segment of the string that contains only these characters. So if the offset and length are omitted, then all of the string will be examined. If they're included, then the effect, if the offset and length are omitted. So I think they're omitted in this case, the length and the offset. That looks like, Cypher Enigma says, that looks like shorthand for spawn. Spawn? Maybe, I don't know. I just got here and didn't realize this was code. Yeah. If you just got here, we're doing Natas level 20 from Over the Wire. So I'll just give you, this is the link, and this is the username password. If you want to join in, you can use these credentials in this website. Okay, so let's see. Yeah, there was no offset and no whatever. If the length and offset are omitted, they are omitted. Then all of the string will be examined. If they are included, then the effect will be the same as calling substring, string, offset, length characters. This line of code, they've got an example here. So variable equals str string spawn, not sure. 42 is the answer to the 128th question. It includes these. So what does this return? This will assign 2 to var because the string 42 is the initial segment of string that consists only of characters contained within this. Oh, okay. How do we, if we know how it works, how do we brute force this? Because I'm not too sure what the SID would be. So the parameters is the string to examine, the character, the list of allowable characters, the offset, the position in the string to start searching. So let's take a look at the this is the string that we have to examine here. So have these been rearranged? Okay, let's feed this line to the AI and let's see what it makes of it. So we discovered that the string provided is part of a transformed SID string of some kind. This is the code involved. Okay, this is part of a Transform Security Identifier, SID, and the validation code checks for allowed characters. We can deduce the following. So, allowed characters. So the allowed characters consist of digits, lowercase and uppercase letters, and a hyphen, although your example lacks it. So this resembles base 62, but with hyphens optionally allowed. So a Windows SID looks like this. Huh. So are we talking about a Windows SID? That's kind of odd. It starts with S1 followed by a series of numbers separated by hyphens. Transformation applied. The SID may have been hashed, encoded, or truncated. So possible transformation steps. So if we take some SID here and then we strip out all the hyphens and the prefix. So the prefix is this. Then it becomes this number. Converted to integer and encoded in base 62. So the numeric part is treated as a big integer, encoded using base 62 or a similar scheme to form this. Really? How to reverse it? Okay, if the transformation is deterministic, you might try to try reversing it by base 62 encoding. Why is it so confident about this base 62 encoding? Reconstructing the SID. If the output is this, split it back into this. If it's hashed, then it's irreversible. Maybe I should take a look at how the cookie changes when I change my user ID code. But then again, we have the entirety of the PHP code, but we're not supplying it to the AI. Maybe we should just include everything and give it to the AI and figure out what it thinks is going on. Okay, AI, solve all my problems. This is the entire web app code. Okay, so it knows that we're dealing with the Natas level 20 to 21. It's a custom session handling script from Overthewire Natas. The goal is to escalate privileges from regular users, blah blah blah. Okay. Key vulnerabilities and exploitation steps. Oh, you know what? It might be taking its answer from some sort of write-up that it has that it was trained on. Custom session handling. The app overrides PHP's default session handler with this. Sessions are stored in files named my session, SID. The session files are written in a custom format instead of PHP serialized format. My write function saves session as plain text. If we control session name, we can inject new lines to add arbitrary session keys, like admin1. Really? Session ID validation. The SID is validated to allow only alphanumeric characters and hyphens. This prevents directory traversal, does not affect our attack. Okay. Set a malicious name parameter. Submit a name with an embedded new9 and admin1. When written to the session file, it becomes name test admin1. Now session admin is set to 1. What? Oh, have I been looking at the... Is... That'd be very funny if it was true. Let's test this out. First, I was really fixated on trying to... Okay, so we changed our name, but I don't think it affected anything. Or did it? Okay, use the same as PHP session ID. The session's file name is based on PHP session ID, okay? Reuse the same cookie to ensure that myRead loads the injected session. Trigger print credentials. The function checks If we injected admin 1, we get their credentials. Okay. Well, that would probably mean that we need to reload the page. Yeah, but we didn't get our we didn't get the password. I wonder how the cookie changed between setting the previous name and this name. Let's copy this and let's paste in this other one. They look the same. Wait, are they the same? Yeah, these look like the same cookie. So what we need to do is we need to... You know what? I want to see what this looks like. Slyborg has just rated the channel with 7 viewers. Hello, Slyborg. Nice to see you. And what were you working on stream today? Welcome, Raiders. My name is The Shy Hat. I do cybersecurity stuff on Twitch. I specialize in trying to get beginners into cybersecurity by teaching beginner cybersecurity skills. Networking. Hello, hello. Hello, Slyborg. Nice to see you. Let's give you a fun little video redeem. How about all the things? This is a fun nerdcore hacker rap song. Here you go.
This one's dedicated to all the hackers.
Rushin Myth, thank you very much for following on Twitch. Thank you, thank you. Okay, so this is, yeah, we're doing the NatasCTF wargame. Natas is a very famous web app wargame where you have to use the password for one level to access the next one, and then find the next password by exploiting the web app vulnerability. It gets very, very difficult later, but we're currently working on a bunch of different write-ups for the various levels. You can find it over at this GitHub page over here. It is a pretty fun game, but it gets very, very difficult very, very quickly. Feral Alias says Burp Suite stuff. You know what? We should probably turn on Burp Suite at this point, because we've been having trouble with this level that we're doing right here. It's level number 20. And we're trying to figure out what this PHP stuff does. Actually, if you want to work on level 20 along with us, let me grab the link and the credentials. So this is the link, and these are the credentials. You can go ahead and join along with us if you figure out what the password is. Arushin Myth just subscribed with Twitch Prime. Wow, thank you very much, Arushin Myth. You are now a full-fledged frog. Thank you very much, Arushin Myth. And let me give you another fun video redeem. How about the it's a Unix system from Jurassic Park.
It's a Unix system. I know this. It's all the files of the whole park. It tells you everything.
So did you know that in 1993, some kids used Unix to protect themselves from dinosaurs? It's true. It happened in Jurassic Park, so it has to be true. Okay, I really need to change the name of that redeem to Jurassic Park, because it's a Unix system is hard to type. Okay, so what are we doing? We're going to start up Burp Suite. We're going to take a look at what comes back from this application, because apparently there's some funny things happening here. So Burp Suite, for anybody who doesn't know, is the industry standard web application testing software that we can use to do web application testing. So let's go ahead and open up the Burp Suite browser, which is connected to Burp Suite. And this Burp Suite browser over here is it's connected to the Burp Suite proxy, which means that anything we see inside of here is going to be recorded by Burp Suite. So let me demonstrate what that means. Let me access Natas level 20 inside the Burp Suite browser. No. Yes. Okay, we need to put in our credentials. Let me get the credentials. So Natas 20, password is going to be this. Sign in. Okay, so it says here you're logged in as a regular user. Log in as an admin to receive credentials for the next level. So now that we have this recorded, we can actually start replaying the request inside of Burp Suite to start doing some testing. So we're just going to minimize the Burp Suite browser. Then we're going to go over to Burp Suite's HTTP history tab. And this is the request that we sent to Burp Suite. Sorry, this is the request that we sent to the web server. So we can go ahead and send this request to the repeater. Then in the repeater, this is all the information we sent. These are all the HTTP headers that we sent along with it. And what I'm interested in taking a look at is the cookie that we retrieve from the website when we successfully access the page. So if we go to the response, oh, I need to send this first. Okay. In the response, we got a session ID number over here. So this is the cookie we need to pay attention to, because I think it's by setting the cookie to a specific value that we become the administrator user. So let me copy this. So you're logged in as a regular user. Log in as an admin to retrieve credentials for Natas 21. And what can we do on this page? So on the page it says we can change our name and we can view the source code. So what I think we want to do is we want to change our name to see how it affects our cookie value over here. So to anybody who's interested, if you're already logged in, you can take a look at the source code for the application by going to this link. So what name are we going to switch our... We're going to switch our name to admin, and we're going to see what happens. So it still says we're logged in as a regular user. I want to take a look at Burp Suite in the post request here. And I want to take a look and see if our cookie changed. So we sent this request to change our name to admin, and we sent it with this cookie here. We should get a new cookie in our response. So let's go over to the response. We didn't get a new cookie in the response. But I think this is a different cookie here. So our cookie in the GET request starts with 34, ends with 3Q. But in the POST request, oh, it's the same. Let me reload the page and see if the cookie changed. Okay, reload this page. And our cookie's the same. How do we make sure that this is a GET request and not a POST request? Okay, let's check Burp Suite. Now this is a GET request. So is our cookie staying the same every time? Let me try changing our name again. So how about HackerFrogs? So we change our name to HackerFrogs. Our cookie's the same. Okay, so what's going on here? So maybe we don't need to we don't need to change our cookie. Maybe the cookie is not the way to go, and instead we need to focus on another vulnerability. So the AI told us that there was something else going on. So trigger Reload the page to read the modified session. The app reads the session file and grants admin access. So, hold on. So it thinks that we're able to inject some sort of code into the session. I'm not too sure what exactly is going on in the code. Let me try to get the AI to explain here. So what kind of vulnerability is at play on this web app? Okay, so the vulnerability in the web app is session fixation attack, combined with session file injection. Session file injection, I've never heard of this. So it's a form of insecure session handling. Okay, here's a breakdown. Session fixation. The app accepts user-provided session IDs without regenerating them after authentication. An attacker can force a victim to use a known session ID, hijacking their session later. So in this application, the PHP session ID is not reset after login or previous changes or privilege changes. So an attacker can preset a session ID, then trick a user or admin into using it. So session file injection through new line injection. So the app stores session data in plain text files with the custom format, key value, new line. By injecting new lines, an attacker could add arbitrary session variables. So in the application, the myWrite function saves session as key1 value new line, key2 value new line. When the name parameter is set to test new line session 1, the session file becomes name test admin1. This injects admin equals 1 escalating privileges. Insecure session violation. The app checks for session IDs for alphanumeric characters but doesn't validate session file contents. This allows malicious data to be written. In this app, string something. Session ID ensures that the SID is safe, but the session file contents are not sanitized. The core issue is improper input sanitization in the session handling. User-controlled input is written directly into the session file without escaping new lines. Custom storage, session storage is implemented insecurely, plain text with a new line delimiter. How to exploit it? Set a malicious session file. Send a name parameter to injected admin flag. Really? Well, I mean, we could give this a try. Reload with the same session ID. Reload with the same session ID. The app reads the poison session file and grants admin access. Okay, well, here. Suppose I am using Burp Suite. How would I conduct this attack? Session file injection vulnerability. Okay. Intercept the request. Okay, we did that. Log in with the credentials, sure. Intercept the post request. Okay. Inject a malicious payload. Modify the name parameter. Alright, well. Let's do this. So in burp, we'll send this request to the repeater. In the repeater, for our name, oops, we'll use the payload that was suggested over here. Okay, this will write 2 lines to the session file. Forward the request. Verify that the session file was poisoned. Append debug equals 1 to the URL to see debug logs. I've never gotten this to work, but maybe it'll work this time. Okay, let's try this. So we're gonna send this. In the response it says okay. Well, I mean, we sent it. The next step is to look at the index.php with debug equals 1. Okay, we got ads on Twitch, so ads are also on YouTube. And let's go ahead and watch some baby birds. Alright, we'll be back in about a minute. So enjoy the birds, enjoy the music, and I'm just going to have a little water break. If you have any questions about what we're doing here, please let us know in the comments. I'd be happy to answer any questions you have. So I'm not super familiar with this web app vulnerability, so I'm just gonna have to press a lot of the I believe button when the AI tells me that this is what's going on. I've never really conducted this kind of web app attack before. Anyways, this is my favorite bird video. It is so ridiculously cute, and these baby Stellar Jays are the best. Okay, let's put the birds away. Let's go and see if we can access this debug page. So over in Burp Suite. Okay, let's change the music. Let's see, what do I have for music? How about we do some Faster Than Light? It's an oldie but a goodie. Okay, so debug equals 1. Does this give us debug? I don't. Whoa, okay. Huh. So debug my write. If this happened, okay, saving in var lib php sessions, my session something something something. Okay, so man, does that mean the attack worked? Let's look for lines like read something. This confirms that the session file was successfully injected. Reload the page. So send a second request. Simply refresh the page or send this. The server will read the session file and grant admin access. I don't think that's true, but let's reload the page just to... So it says you're logged in as a regular user. But this is very interesting that I can get this debug output here. Anyways, let's report to the AI that it is completely wrong. Well, maybe not completely wrong. Okay, so this is the output I got from the app after following the steps. Okay, so let's troubleshoot and refine the approach. So analysis of the output. Session file was empty. So read square brackets means that the session file contained no data. So the my write function failed to save the payload. The server cleared the session file. The new line injection might not have been processed correctly. Okay, so intercept a normal post request, name equals test, to check if the session file is created. And then view the debug output. Okay, we can check that. So over in the Burp Suite browser, we still have debug equals 1. We're going to change our name to, how about the Shy Hat? Change the name. And then access the page with debug equals 1. Okay, so it read in the name here. So the Shy Hat, and then we can try to send a new line. New line admin 1. If we change the name there, and then we give the debug. Session file doesn't exist. So it looks like this attack doesn't quite work. Hold on, maybe I can replay this in Burp Suite, and we can send this with the debug flag. So let's send this to the repeater, and in the repeater we're going to give the debug equals 1 and send this. In the response, do we get debug in the response? So reading from it did read this, but I don't know if it interpreted this as a new line or not. Okay, so what can we do from here? If we reload the page, it doesn't give us admin access. So ensure that the new line in the space are URL encoded. The new line in the space have to be URL encoded. Okay, well, let's try that then. Okay, so whoops. So over here, we're gonna make sure that the new line in the space are URL encoded, and we're going to send the debug flag over here. We're going to send the send the request. In the response, it still says we're logged in as the regular user. What is the feral alias asks, what is the %201 after admin? So %2 is %20 is the space. So you're asking about this, right? So this is URL encoding for the space character, and then the 1 is just the number 1. So the new line is %0A. Shouldn't it be equals? I think the way the app works. Let me take a look at the source code here. So we need to pay attention to a bunch of different stuff in the source code. If you're looking at the level along with us, then it's going to be at this link right here. So let me find the word admin. Session admin equals 1, then it says you're an admin. Admin, session, and session. Oh, wait. We need to set our name to admin as well. I'm pretty sure. So do we need to set... Okay. Let's try the attack one more time, but we're going to send the name as admin. And one more time, the source code is looking for admin equals 1. Maybe we need to send admin equals 1. That is true. First of all, let's try this one first. So admin, and then admin equals 1. In the response, still says we're logged in as a regular user. Debug name admin. Okay, let's try admin equals 1. See if this changes the response any. Okay, it worked. Wow. Feral alias. Thank you for the suggestion. Woot. Yeah, we did it. Jeez. Okay, let's see if we can do this manually. So let's go to back to the web app over here. Okay, so we're gonna do set our name as admin, new line, admin equals 1. Change your name, and then reload the page. For some reason it doesn't work here. I'm not too sure why it doesn't work in the web app, but it works in Burp Suite. So we did get the password for Natas for Natas level 21. It's this. Let me copy this. We'll try to figure this out as we go along. So this is for Natas 21. Let me add this file. So it's a new file. We're going to call it 21.md. So we need to do username, password, method of solve. Username is Natas21. Password is this. We don't know what is... Oh, we need to identify the vulnerability as well. Let's commit these changes. So first of all, we should probably confirm that the credentials work. So let's do that over here. So this is Natas level 21. Natas 21, password is this. Oh, what is going on here? Anyways, to everybody who's keeping track at home, these are the credentials for the next level. But oh, load. There you go. Okay, so it says this website is co-located with HTTP Natas21 experimenter.natas.labs@overthewire.org. I have a feeling that this has something to do with host header attacks. But we probably need to take a look at the source code first. Before we move on, I want to make sure I know what I'm doing with Natas level 20. With Natas level 20. So this doesn't work. Is the reason this doesn't work because it's not URL encoded? Because in Burp Suite, it's URL encoded like this. So maybe we need to add this URL encoding over here. Okay. And we can also send the debug flag. So admin equals 1. Yeah, I'm not sure why it's not working out here. Try. No. And copy this exact thing. Yeah, doesn't work. But in Burp Suite it does. I wonder if it would work if we sent this in curl. Okay, how would we do this in curl? How would we send this payload in CURL? We need to include... Yeah, how do we send it in CURL? Actually, did it tell us how to do it in curl up here? So, Burp Suite. This is still Burp Suite. Okay. Curl. Yeah, this is the curl curl format. Let's try this out. Okay, we've got our curl here. So first of all, let's what we have here. So curl debug 1. This is our cookie, and we need to send our data. So strangely, there's no... Okay, so we can put in our Natas 20 password here. This is not the way you do it. We should probably be sending this as a user. I think I've got the format for sending this in my GitHub over here for, I think it's level 4. Yeah, like this. So -u and then the Natas stuff over there. So we need to format this correctly. So Natas 20, and then we provide the password. We'll stick this between some single quotes. What is the password for Natas 20 again? Okay, this is the password. Paste it in. Session callback unknown. That, I think the reason why that didn't work is because we don't have a valid cookie. Let me get a valid cookie. So we got our, let's see, Natas 20. I'm gonna get the valid cookie from the browser here. Okay. Now we can send a valid cookie. So we've got a valid cookie here. And we should send a post request. Okay. Logged in as a regular user. Session file doesn't exist. Let's try admin equals 1. Okay, this triggered the admin output. So name set to you're an admin. The credentials for the next level are this. Natas 21 password this. Okay, so we've got a working payload script. So let's go ahead and record this in the write-up, and then we can finish this level. Okay. So web vulnerability in this case. Can you explain how that script works real quick? So feral alias, do you mean the curl command? So I'll just paste in the curl command into chat. Not script. You mean the curl command here? Yeah, I can explain how the curl command works. Let me start editing this file first. So the method of solve is we need to inject a new value into the what is the file called? Into the session file. We've got our curl command over here. So what is the web vulnerability? So according to the AI, it says that this is called a session fixation attack, I think. Let's fixation. So the vulnerability in this app is a session fixation attack combined with a session file injection, a form of insecure session handling. Okay, so it's session. This isn't something I know very much about. It's not something I learned a lot about in my in my studies for web app vulnerabilities. Where are we? Session fixation and session something injection. Session injection. But let me explain the what exactly is happening in the code over here. So this is the curl command. The curl command lets you send and receive web page content, and the web page content that we're getting in this case, we're going to send a post request. So a post request is going to send some data to the web server. So we're setting a username, and because the web page has basic authentication enabled, you have to send your credentials with every request. So the credentials are Natas20 and this password here. So we're sending it to this URL right here, which is Natas20 natas.labs/overthewire.org, and we're setting it with the debug flag over here so they can send us some debug output along with its response. And we're setting it with the cookie. So the cookie is this PHP session ID that we got when we logged into the website. This can be this only needs to be a valid cookie. It doesn't really matter too much. And we need to send some data. In this case, we sent data. Oh, you know, that's odd. It didn't matter. It didn't matter what name we set ourselves as. We still set the admin cookie to true. Huh. Let me double check this in Burp Suite. So if we send not an admin and then send this, that still gives us the password, right? No, this does not give us the password. I need to double check this. Okay, let's set our name to admin. Send this off. Debug name set to admin. You're logged in as a regular user. So now we're a regular user. Admin equals 1, name admin. But it didn't give us the password. Let's resend that request. Let's see. Cyber Dante says you're injecting another parameter along with the name parameter. This reminds me of something called CRLF injection. Oh yeah, CLRF injection is injecting new lines, right? So Cyber Dante, yeah, welcome to the stream. You showed up a little earlier, I'm pretty sure. We're currently working on Natas level 20, and let me give you the credentials if you want to do some monkeying around in here. Here's the URL. And where's that password? This is the password. Log on as admin to receive return credentials for Natas 21. But what we were doing in curl. So in curl, we can set our name to. We didn't set our name to admin, but we were still able to get the credentials for Natas 21. So should we set our name to admin? Yeah, I'm confused. I'm confused why it works sometimes but not others. Session file doesn't exist. So session file doesn't exist here. I mean, we managed to get the password for the next level, but I'm not too sure how the hack works. I probably need to do some more research afterwards. So let's just not send this. Login as an admin. Try no name. No name. Session file doesn't exist. You're logged in as a regular user. So let's first of all, let's set our name to admin equals 1. And then let's send a regular request without any information. Still says we're logged in as a regular user, but let's try accessing the page again. Still says we're a regular user. It does say that we are admin equals 1, but I'm not sure why we're logged in as a regular user. Anyways, I'll try figuring this out later. Let's access the new level and see what's going on that one. But yeah, it's still a little bit of a mystery for Natas level 20. But we do have we do have access to level 21, so let's take a look at that. And I'm just gonna leave this as it is right now. I'll come back to it later. Okay, this is Natas level 21. The website is co-located with natas21-experimenter.nataslabs.overthewire.org. What happens if we access this page? So we're gonna put this in a new tab. experimenter.natas.labs.overthewire.org. Okay. So the username is natas21. The password, let me get the password. There's going to be some weird trickery happening on this page. What the? Natas21 CSS style experimenter. It says hello world. That's Change example values here. Align center, font size 100, BG color yellow. We can set the BG color. This tells me that there's going to be some sort of injection in here. So can we set it to blue? Can we set it to red? Can we set the font size to 200%? Yeah. Can we align it to the right? So the code for this page is probably going to be different from the code for the other page. Let me put this source code in a new tab. Thank you very much for following, Pharaoh Allies. Hey, nice to see that you've joined the HackerFrogs. Why don't you have a hack the planet? Here you go.
Hack the planet! Hack the planet!
Shut up and get
And to anybody who's interested, you can also send little video redeems by using the exclamation point redeem command, along with whatever you want to redeem. So, for example, if you want to redeem Hack the Planet, it would be exclamation point redeem space Hack the Planet with no spaces. I don't know if you can do it. I think you have to wait a minute before running it. Otherwise, it's on cooldown right now. Anyways. Let's take a look at... Thank you very much for following, Haplo Echo. Haplo Echo, welcome to the HackerFrogs. Why don't you have a bully bird? This is one bird bullying another. Okay, what do we got? So, let's see. Example. What kind of... So we can change our...
Hack the planet! Hack the planet!
Shut up and get
Thank you very much, Arushan Myth, for redeeming Hack the Planet. Thank you. Hack the Planet, that's what we do. So let's see, only allow these keys. So valid keys are array align, center, font size 100%, PG color, yellow. So is this some sort of injection? I have a feeling this is some sort of injection. CSS style experimenter. So the question is why is this page associated with the regular Natas 21 page here? Let's take a look at the source code for this page as well. Oh, what's going on here? Okay, so function print credentials, if session and array key exists, admin session, and session admin equals 1, then print you're an admin, the credentials for the next level are this. Or else you're going to be, you're logged in as a regular user, log in as an admin, or retrieve credentials for Natas 22. So session start, and then print credentials. Okay, so we might have to set our session in the other web page and then come back here to get our password. So we're just a regular user right now, so we probably need to set our user session in the other page. But on the other page, there's... this is where the sessions start. Okay, so the session start function is run here as well, but we don't know what is in the session start code, because it's not here. Arishan Smith, thank you very much for redeeming the frog song. That's that was just a fun little sound effect I found on a website. It sounded like me, like it was some sort of like digital like frog croaking, but that's the frogs, the frog song. So if update was submitted, store it. Okay, so we probably want to save one of these post requests inside of Burp Suite. So let's go ahead and do that. Cyber Frogs. Yeah, we are the HackerFrogs and we do cyber stuff. Okay, so Natas level... This is level 20. We need to access level 21. So I'm going to log on inside of our Burp Suite browser. It's going to ask us for our password. So the password is Natas21. The username is Natas21. Where's our password? Let me get the password. It's here. Sign in. Okay. And we'll also access the other web page. Huh. No response received from remote server. Let's try. Okay. Yeah, no. We managed to get it to work. Okay, so the post request. Let's do a post request here. So let's change it to green because we're HackerFrogs. Actually, what happens if you send an invalid BG color? So it turns... It doesn't show you anything. If there's no... So center... We send HackerFrogs here. Then it sends it to the left. Is that the default? Yeah, it looks like the default is left orientation. Okay. Anyways, let's go ahead and take a look at Burp Suite now that we've recorded this this traffic. So in Burp Suite, we can go to the proxy HTTP history tab, and we've got all these post requests. We can go ahead and send one of these to the repeater. So we're sending these parameters right now. So we're sending align center, font size 100, 100%. So this is the URL encoding for the percent sign. So %25. BG color is yellow, and submit equals update. Submit equals update. So we might be able to... What do we need to set to get access again? Let me look that up. Session admin equals 1. Admin equals 1. It couldn't be as easy as sending some sort of session equals admin, or admin equals 1 with our request, right? That would be ridiculous. So if we send in here admin equals 1 and align equals center and something something, we send this off. In the response here, it doesn't matter, but if we go back to okay, it still says that we're logged in as a regular user. Okay, so what do we know? We know that we have to set the admin to 1. In order to get the password to the next level. So if session and array key exists, admin session, and we also need to set our name to admin, but we can't set our name. We can't set our name inside of here. Can we set the debug flag here? Debug equals 1. Okay, looks like the debug flag doesn't work. Does it work on the other page? Here we're going to do debug equals 1. Okay, so the debug flag works here. Session contents array. Array? Okay. Can we set background color yellow and then admin equals 1? Get the debug flag. Okay, so yellow admin equals 1. Didn't quite work. If I reload this page, it probably doesn't give me the password. Okay. But you know what? We can start working with this. Let's go ahead and go back to Burp Suite. So in Burp Suite, proxy HTTP history. Yeah, let's go ahead and play around with this request. So in this request, we tried to set the admin This doesn't look like the new line, though. We want a new line, so let's do... So new line is /n. Let's convert this to URL encoding. Convert selection to URL encode key characters. URL encode all characters. That doesn't look quite right. Okay, URL encode. %0A. 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 So admin equals 1. I think they've already encoded that. Let's try setting this. What happens? What is in the response? Capital A. Oh, it needs to be capital A? Okay, okay. I think you're right. Let's try sending that again. So we're gonna send this with the so in our request we can also set the debug flag. That's gonna help us a lot. So debug equals 1. Let's try sending that. So yellow admin equals 1. Submit. It doesn't look like it really went through. Let's... Okay, okay. Let's see. Let's see if we can get the AI to solve the thing for us. It worked last time, but yeah, I really want to come back to these levels to understand what is going on better. But let's just try to solve the levels with the help of the AI first. Okay. So, new level, this is the code. On another page, this is the PHP code. And the other page is going to be the experimenter page, like this. So I really wish I understood more about PHP, but it's not a language. You know what? Maybe that should be on my bucket list. I should learn how to code in PHP, code web pages in PHP, so this stuff all doesn't seem as foreign. But DeepSeek does seem pretty good at working through the logic to finish these levels. So this level introduces a session handling system, with a restricted set of allowed keys, align, font size, BG color. Your goal is to escape privileges by setting session to admin equals 1 to retrieve the password. Right. So session initialization. Session start is called on both script, sharing the same session data. The first script, print credentials, checks for session admin equals 1, session update logic. The second script allows updating session variables only for predefined keys, such as align, font size, BG color. However, it uses a flawed loop. For each request as key equals value. So vulnerable to parameter injection. It iterates over all request parameters, not just valid keys. So each time it's gonna update the admin parameter as well. So the debug 1 flag leaks session contents. Okay. You know what? I've been really avoiding trying to say this word because if I say this word, my YouTube live stream is going to get ad limited, which means I don't earn money on my YouTube stream. So every time I encounter this word, I have to say that. So okay, so the goal is to get session ID admin equals 1, okay? Session admin equals 1, despite the valid keys restriction. So submit a request, okay? Intercept the update request, sure. Add and admin 1 to the post data. I thought I did that already. To see if this was set. Okay, so I'm not injecting into a parameter right now. I'm just adding another parameter. Is that what I'm supposed to do? Okay. If that's the case, this is what I'm going to do. In that case, I'm going to tack on to the end, and admin equals 1, and submit equals update. So if we send this, what are we going to get in the response? Okay, so it looks like admin equals 1 was submitted. So let's go back to the Burp Suite browser and update the page. Okay, it didn't work here, but maybe we can get the response on the other page. So the other page is going to be this one. Oops. Okay, let's try sending this. So the debug tag doesn't work here. Yeah, it still says we're a regular user. It's gotta be something I'm doing wrong. It does say that it set admin to 1. Array? Okay, so debug, align, font size, BG, admin. So do we also need to send a username? I need to check the source code. If session and array key exists, admin session and session admin equals 1, you are an admin. Still says we're a regular user here. Okay, maybe we should do this with curl, and see if curl gets us some different response. So first of all, I should probably get the curl command. I had the curl command in the level 20. Okay, here's the curl command. So we need to make sure that we're sending it to level 21 instead. We need to make sure that the password is the same as the password we're using right now. Level 21 password is this. Whoops. Oh, I shouldn't have done that. Okay, let's paste that in. Ads starting in a little bit, but that's alright. We'll take a break and refresh ourselves with some water. That'll be great. Okay, so for this, we need to get... So this is the post request. We're not going to send... Well, we'll send the post request. That's fine. But what we want to do is we want to send the post request to... Oh, we need to get the cookie. Where's our cookie? PHP session ID. Okay, we've got a... I mean, is this a valid... It says we're logged in. We were able to access the page okay. So I guess we don't need to really update our cookie too much. Okay. So we're going to send our post request, and the post request we do need to set our debug flag. We also need to send a bunch of other information which we can get from Burp Suite. So Burp Suite, in the request, we've got all this stuff. We can paste this in. So we've got the admin equals 1, all that other good stuff. And we need to make sure to send it to the right host. So the host is going to be... We're going to take a break. Let's take our break. How about we watch another bird? There you go. Hold on, I'm going to take my water break. Just a second. That is a rare bird. That is a what is called a varied thrush. So the varied thrush has...
We're in.
Shall we play a game?
How about global thermonuclear war?
Thank you very much, Arushin Myth, for redeeming the War Games redeem. Thank you. To anybody who hasn't watched War Games, it is a really fun hacker-related movie. It's one of the first, and it's all the way from like 1989 or something. It's pretty old. But anyways, let's finish our break. Okay, so what is the host for CSS Style Experimenter? Okay, let's paste this in. Okay, so I think this is what we want here. So we send this request to change our session, and then we access the original page with the post request. Need to get rid of the debug flag. What happened here? Oh. Oh, it worked. It worked. We're in. Shall we play a game? How about global thermonuclear war? We did it. Yeah, we got the we're an admin. The credentials for the next level are this. Great. You know what that means? We can do this redeem.
What are you?
I'm system root.
Wow, we did it, everybody, and just in the nick of time too. Anyways, we got our password for the next level, Natas22, and the password is this. So for everybody who's keeping track at home, that's Natas22. Password is this. Let me record this password before we do. Well, actually, let's do our little write-up. So that one was easier to understand than the previous level, I think. Man, I love this music. Okay, so Natas22, let's add that file. 22.md. So username, password, web app vulnerability, and let's see, method of solve. So the username is going to be Natas21, no, 22, and the password is this. Okay, let's get these changes. You know, just for fun, we'll take a look at a preview for Natas22 at the end of the stream, but let's do our write-up for Natas21. Okay, edit the file. So the web app vulnerability is insecure session handling, I guess. Insecure session handling. Session parameter. Session parameter injection. So the vulnerability is session variable. Oh, session variable injection. Okay, so let's session variable injection. Well, I mean, it's still kind of the same thing, but let's go with what they suggest. Okay, so this web app allows allows session variables or session parameters to be set through the web app via a post request. Oh, sorry. This might seem a little bit small. Let's make everything a little bit bigger. Okay. This is much easier for people to see. So the web app allows session parameters to be set through the web app via a post request. The code does not prevent additional parameters to be set at the same time. Legitimate parameters are. So we can set our admin, I guess, session parameter to true to gain elevated access to the web app. And let's include the 2 curl commands that we sent. So the first curl command we sent was the post request, this one here. So I'll paste this in a chat so you guys can take a look. If there's anything you don't quite understand about what we're sending to the web application here, let us know. Let me know in the chat. I'll try to explain what's going on. But this is basically all of the information that we're sending through through Burp Suite, but instead we're using a curl command instead. And everybody knows when you're when you're working on the terminal, you're a real hacker. So let's go ahead and finish this off. So this is the first command here, and I guess we can leave a little comment. This command sets our admin parameter to 1, which is required to gain access to the flag, to the password in the main web app page. Okay, and then the second command is this. Okay. All right, so let's do a little preview of Natas level 22. This level was easier to understand than the previous level. I'm not too sure why we got some inconsistent results on Natas level 20. I'll have to do some additional research after the stream is over. But let me take a look. Let's just do a little preview of Natas level 22. So after this, there are about a dozen levels left in the Natas game. Let's go ahead and check out the next level. So Natas 22. Arushin, it looks like you... Yes, for some reason it didn't go through correctly. Let me redeem that for you, Arushin. Let's see, redeem... Yeah.
This one's dedicated to all the hackers.
Yeah, I don't know why it didn't go through the first time. Did you add like an extra space or something? Not too sure. But let's try logging into this level. So it's Natas 22. It's always the little details, yeah. Okay, so that's the password. Oh, there's nothing here. This is funny. Okay, we might not have enough time to completely solve this level, depending on how weird the application is. We can certainly look at the source code. And there you go. What is this? We've got two pieces of code. So session start, if array key exists, Revelio. Revelio. It sounds like a spell from Harry Potter or something. Revelio. Only admins can reveal the password. If array key exists, Revelio. If not, array key exists admin and admin equals 1. It's going to take us to this. Oh, What is this endpoint? So if array key exists Revelio, you are an admin, the credentials for the next level are this. Huh. That's odd. So is this index.php? This is index.php. So how do we inject in here? So like the previous levels, unlike the previous levels, there's no method to inject our session variables. But are we going to be doing this through parameters? So are we going to do something like if array key exists, revelio equals something. Revelio. So we would do something like revelio equals 1 and admin equals 1. No, that wasn't it. Okay, you know what I want to do? I want to access this level using curl, because we might get some additional information if we do that. So let's try. So level 22. We need to get the password for this level to pass it over to curl. How about this password? Okay, so what happened when we sent this request? We got the header, and we don't see any of the PHP code. So if you're dealing with PHP code, you'll never see it in the source like this on your web browser, because all the PHP code is going to be executed, and it doesn't show up in the source code unless you're looking at something that was intentionally set up like this. So in this case, how do we set... Just ask the AI, dummy. Okay. How do we set our session parameters in this app? Okay, so it checks for the admin session token when the revelio parameter is present in the URL. If you're not an admin, it redirects you to... How do we set this? So since the app doesn't provide a direct way to set session variables, we need to take advantage of PHP's default session handling, or find another way to inject this key. Oh, we could try via cookies, okay. So it's whatever cookie and then end it, and then this won't work directly, okay. Unserialization. Cross-site script session access. Okay, everybody. I'm getting really hungry, and I might I'm gonna have to call it over here. But thank you everybody for following and subscribing. It's been a great stream, and if you learned something, while watching this stream, I'm very, very happy. Let's see if there's any good InfoSec streamers who are streaming right now. Blackhack Knock. They're a temporary channel. Maybe we shouldn't be raiding into them, but let me take a look at who's on Twitch right now. Okay, oh, SnowX Cone. SnowX Cone is one of my streaming friends, and they do a lot of leak code and other fun stuff on their channel. So if you want to learn how to code in Python and how to do leak code stuff, there was somebody in my chat way earlier today asking about leak code. So maybe they would really appreciate it. But when you arrive on SnowX Cone's channel, if you could give this raid message, I would really appreciate it. So it's going to be frog, hip, hop, hack, frog, just like this. So when you arrive on SnowX Cone's channel, please give this raid message. I would really appreciate it. And before we go, let's shout out all of the great chatters today. So Arushi Myth, thank you very much for coming by and being a great HackerFrog. Feral Alias, thank you. Thank you very much to Slyborg for raiding in today. That was very much appreciated. And who else? Cybernerd Dante showed up. There was... I'm scrolling back to see who else was talking. Cybernerd Cypher Enigma, thank you. Arushi Smith, thank you for the Nyan Cat. And Cybe on Bush. All sorts of great new HackerFrogs today. So let's start the raid. Hey everybody, we're going to be streaming one last time this week on Friday. On Friday, we're going to be doing a lot of coding. So we're going to be doing assembly coding, we're going to be doing C coding, and we're going to be learning more about reverse engineering. It's going to be a lot of fun, and I hope to see you there. Catch you later, and say hi to SnowX Cones for me. HackerFrogs out.